Hello everybody. What kind of hijinks are we getting ourselves into today? Well, what you see here are 22 internal modems. They range from being made in the mid-90s to the late 2000s. We've got 8-bit ISA modems, we've got 16-bit ISA modems, we've got PCI modems, we've got hardware-based modems, we've got soft modems, we've got modems that are pretty high quality in their manufacture, and we've got modems that are just really sludgy modern crap. And in today's video, we are going to test all of these. We're going to go through them one at a time, put them in a computer, and we are going to see how well they work. And I've got a bit of a regimen worked out as to how we're going to assess the quality of these modems. Of course, I've got an internal telephone network here served by my Northern Telecom Northstar key telephone system. And so I've got a couple of things on the Northstar system that we're going to call. I've got my US Robotics Courier v.everything set up. So we're just going to call that, assess how well it connects to another modem on an ideal telephone line, which is what the Northstar generates. But we're also going to see how well each of these modems connect to an ancient Bell 103 compatible modem. And to test that, we're going to use the Leach CSD 5300, my broadcast clock system driver that we made a video about earlier. It has a Bell 103 compatible modem, and we're going to see how well each of these modems connect to that modem. Since setting up the Leach and putting it on a public telephone line that anybody can call, I've gotten about 70 calls to the Leach, which is amazing. And I've discovered that a few modems that some people have tried calling in with, almost certainly very modern modems, they won't connect to a Bell 103 device. They just won't try falling back to a Bell 103 handshake. Which is just nuts to me. And so we're going to see if some of these modems, probably the newest ones, if they'll even try to connect to the Leach. By that same virtue, when we connect to the Leach, we'll try pulse dialing as well. We'll see if there's any of these modems that will refuse to pulse dial and will only tone dial instead. So those are the two local devices we're going to call. But we're also going to call modems out in the world. I'm going to dial into my favorite BBS, Kludge, with each of these modems. We'll see how well these modems perform, not only connecting to a remote modem somewhere else in the world, but doing so over a VoIP telephone line, because that's what I have here. VoIP telephone lines can be very hard to get a modem working well on. And my VoIP line tends to do pretty good. But we're going to see if any of these modems just have troubles connecting to stuff, either because of my VoIP telephone line and the challenges it creates, or just because the quality of the modem's not that great. About half of these modems are 56K modems, so in addition to Kludge BBS, when we test the 56K modems, I'm also going to call the 2600 network. That's a network of BBSs that are served by a 56K capable dial-up gateway. 56K is notoriously hard to handshake on a VoIP line. In a previous video, we looked at a V.92 US Robotics Courier modem, and even that modem, a Courier, the best modems you can buy, even it struggled to make a 56K connection. So we're going to call the 2600 network on the 56K of these modems, and we'll see if they do better or if they do worse, and just how they work overall. And I'm pretty excited. There's a big spectrum of build quality and hardware and age and everything else in the modems you see here. So I'm really excited to get into it and just see how well each of these modems perform. A lot of these modems are software modems, so I'm going to need to find drivers, and we'll see how easy it is for me to find a driver for each of these modems. But also, it's going to be really interesting to see how well the soft modems work compared to the hardware-based modems. I always recommend, if you're gonna play with modems at all, don't bother with soft modems at all. Almost don't even bother with internal modems at all. Just get a serial modem if you can. But it's going to be really interesting to find out how good or bad the soft modems are, and if there's a range in quality between them. I acquired the bulk of these modems 4 or 5 years ago. When I first got into modeming, I basically put out a call on a couple of vintage computer Facebook groups that I was in at the time. And I said, hey, I'm figuring out how to play with dial-up modems. If you have any unwanted dial-up modems, please send them my way. I'll pay shipping, stuff like that. And so these modems here came from, I think, 2 or 3 different people. And I think actually most of them came from just one person who just had them sitting in their spare parts bins. And these people are like, heck yeah, don't want to send good working hardware to e-waste, but what the hell are we going to do with modems, right? So they sent them my way, and I really appreciate them. And actually one of those people sent me the US Robotics Courier V.Everything, which is super rad. And so that's how I acquired all these years ago, and I never knew, at the time how I was going to use them. I actually did put one of them in the IBM portable PC of all things, and I used one of them in that for a while. But I've had the idea just recently to get these all out and maybe do kind of a shootout between all of them. So that's what we're going to do. So, without further ado, let's clear off the table here. I will set up a vintage computer. We're going to use the Socket 7 machine today because it has both ISA and PCI slots. And let's get started with our first modem. So the first modem we're going to look at is one that we actually can't test. We're not going to test this thing today because it is neither ISA or PCI. Now you may look at this and say, well, Flo, that looks an awful lot like a PCI bus connector, and you're right, and actually it's exactly the same as a PCI connector. But take a look at where the bracket is with respect to the notch on the bus connector. It's like a PCI card but built backwards. And I've had this in my possession for years, never knowing what it is. Back in the day, I thought maybe it was a microchannel card, the architecture that IBM Personal System 2 computers use. I had since learned that it's not an MCA card. My best guess today, and I've put a post out on my Mastodon page, and I'm still, as of this taping, looking for confirmation. But my best guess is that this is an NEC PC98 compatible card. The NEC PC98 is a microcomputer platform. I think it's IBM PC compatible, or at least partially, that NEC sold for, I think, 10 or 20 years. I know nothing about it, so I could be saying wrong stuff. But yeah, it's a series of computers that NEC made for Japan. And I guess the later ones use the PCI bus, but I haven't been able to find much info. I only found one web page that said they use a PCI bus, but the socket is flipped around so that ordinary PCI cards can't be inserted. You have to use NEC's own cards. So I think that's what this is. Between the construction of the card and the fact that this actually was made by NEC themselves. So this card's from 1996. It's a Rockwell-based modem. It's got the RCV 288 DPI chipset, so this is probably a 28.8K modem. And yeah, that's all I can say about it. It's too bad. It's a nice looking card. It's too bad we can't test it. This looks like the best build quality card. There's just a whole lot of componentry on here compared to all the other modems we're going to be testing. So sure, it's a nice card, but we are not going to be able to test this one. So I'll be interested to see if I hear back if it is a PC98 card or if it's something different entirely. But either way, I'll probably just list this thing on eBay for very cheap because I can't test it. And whatever it is, maybe it can serve someone well. But we won't be able to test this thing today. So on to the next one. So for our first modem, I thought we'd better start off with a bang, something that we know is going to work and probably perform just fine. So I grabbed this Rockwell-based modem, and you can tell just by looking at it, this is a hardware-based modem. And it's got the Rockwell RCV288 DPI chipset. That's a V.34 28.8K chipset. With 14.4K fax capability and voice capability. But the funny thing is, you look at the back of this thing, and it says 33.6K on it. So I believe Rockwell chips by this point were firmware upgradable. So the company that made this modem must have been using old chips that they then upgraded to support 33.6K. Which is kind of neat, but we'll have to test that and see if it really is 33.6K. So this modem was made in 1996, and it's 8-bit ISA, which is kind of neat. So despite being a new enough modem that it's 33.6K, you could stick this in an IBM PC or compatible, and it ought to work just fine. In fact, the bottleneck may be the CPU and the bus speed of the IBM PC itself. But I looked up this V1428VQH. This modem was made by ASCII Computer Corporation in Taiwan. So let's see how good of a modem they made. Let's plug this in, and of course, because this is, I'm very certain, a hardware-based modem, I should be able to just shove this in the socket 7 machine, and it should just show up as a serial port with a standard Hayes compatible serial modem connected to it. So I should be able to just boot into DOS, boot up Bananacom, and it should just work and be addressable, no drivers to install or anything. So let's find out. All right, we're booting up the socket 7 system. This system, of course, has both ISA and PCI slots, so I'm hoping I can use this one computer to test a lot of these modems. This computer has Windows 95 installed, but we're not going to boot into Windows 95, at least for as long as we don't have to. I'm going to do this straight from DOS. So, I have our first modem installed, and I'll let you in on a bit of a secret. This is actually take 2 of testing this modem, because the first time I tried it, this modem was actually completely dead. Bananacom did not detect it at all, and it was just totally dead to the world, like it wasn't there at all. And so I tried something, and that something actually worked. What I did was as you could see, the 3 biggest chips on this modem are all socketed, and so I reseated them all. And that was it. This modem is working now, which I find very amusing. So yeah, if you've got something with socketed chips and it's not working, give the most simple fix a shot and just reseat those chips. So this modem seems to be working just fine now, but we'll find out when we make some calls on it. So I'll fire up Bananacom here. And you know, it's funny, this computer, motherboard's from 1997, and I would think the serial port can run at a much faster speed than 57.6. But Bananacom only wants it to run at 57.6. So anyway, that's fine. If we were actually making a connection with this modem and transferring data, the 57.6 kilobaud serial port speed could be a bottleneck, especially if we're getting a good quality connection and v.42 bis compression or MNP compression. But we're just making connections. We're not actually going to be transferring any data, so this is fine. So the modem is alive, and we'll just run through the ATI commands quick, see if there's anything interesting. A lot of times modems won't have anything very useful in the ATI commands. ATI 3 does give us a hint that it is indeed a v.34 modem. Shows us what the data pump chip is, an RCV 288 DPI, and the revision even. And that might be it. Oops. Yes, that's it. So, obviously, this modem would have been cheap. You know, it's a Rockwell-based modem. It would have been a lot cheaper than an equivalent like US Robotics Sportster. So, we don't get as nice features as listing the current settings. There's no onboard phone book, at least that I know of. Stuff like that. So things are much more basic. As a matter of fact, I would be surprised if, yeah, you cheapskates, you can't even get it to define the commands or the S registers. So, you know, God knows, we could possibly, we can almost certainly find a data sheet for the chip, and it'll possibly tell us what S registers we can set. We possibly have the ability to slow down the modem, but I'm not going to go that in depth in this video. So let's start. We're connected on a Northstar extension. I've got my US Robotics Courier v.everything on another Northstar extension. So let's just call the v.everything, and hear the handshake. Hopefully it handshakes and makes a successful connection. I've got another microphone pointed at the modem. So you're just going to be listening to the modem's internal speaker, because we might as well get the full experience of what this modem sounds like, even through a crappy piezo buzzer. So let's see how it connects here. It is dialing. Wow, that was a very quiet piezo buzzer. I didn't even hear the DTMF tones or the dial tone, but we did connect. Now, it says here, connect 38400. So this modem has been annoyingly configured to not display the modem connection speed. It's also not displaying any of the features like data compression or anything like that. I believe it's reporting the serial port speed, which is annoying, but we can change that. It's very annoying when modems do that, but a lot of cheaper modems did that for some reason. So we'll hang up here. And I'm trying to remember what the command is to display the result codes properly. I think it's ATW1. Let's try that and see if it works. Let's see if the redial command works. Actually, first, let's turn the speaker up. We'll go ATL3, put it on the loudest setting. I might regret that, but let's find out. I heard it dial, and I hear it ring. I actually had to turn down my other recorder here. That was a little too loud. Yes, so now we get, it says carrier 33600, so that's the actual DCE to DCE speed, the speed over the telephone line. Protocol, it says LAPM, that denotes v.42 error correction. And then below that it says connect 38400. That's once again the serial speed. Why is it reporting 38400? I am not sure. It should be reporting 576. Anyway, so that's how you can get one of these modems. And also annoyingly, it does not, it actually does not put the result code in the standard haze format, but the modem seems to dial up just fine. So our next test, let's call the Leech CSD 5300. Can this modem successfully connect to a Bell 103 modem, or has it been neutered in such a way that it'll only connect to faster modems? Let's find out. Also, I'm going to see if it can pulse dial. So I've typed in ATDP 37. So let's see if this modem will pulse dial. Yes, it will. Yes, it did. And there we go. And annoyingly, it still says connect 38400. But anyway, other than that, it seemed to connect just fine. It does say carrier 300. But yeah, very annoying result code format. This is not a haze compatible result code format. There we go. Perfect. All right, let's get out into the world. I'm going to call Cluj BBS. Let's see how it does with that. So ATDT, I'm going to use line 2. 312-654-0090 is, I believe, the number. I hope that's the number because I don't have it in the dialing directory. So a little change from the last time we played with modem stuff. I switched the trunk cards around in my Northstar system. So I'm using the older trunk card now, and that trunk card has actual relays in it. And I've set it to pulse dialing. So when I dial this number, you're going to hear the Northstar system pulse dialing quite loudly, actually. It's very cool. And so it's actually going to take quite a while for the line to start ringing because it's got to pulse dial the number. Just because it sounds cool. I sure hope this is the right number. I'm going off of memory. Wow, I'm impressed. That actually did better than the V92 courier that I showed in that video. We only connected at 9600, but we're inside the Northstar system, so we're going from analog to digital to analog to digital to analog. So the quality of the connection has been ruined through all those conversions, and we still had what sounded like a perfect V.34 handshake, and we're connected at 9600 bit per second. That's quite impressive. I'm very impressed. That's great. Call hasn't dropped yet. Oh, this modem actually works pretty well. The only annoying thing about it is it's non-haze compatible result code format. Quit and goodbye. Next, I've got another Rockwell-based modem that should also be a conventional hardware modem that should also just drop in and work just fine. Also 8-bit ISA. And this modem, I had to look up the FCC ID on the back, but this was made by GVC Corporation, also of Taiwan. And I think this might be the oldest modem of all the ones we're going to look at. It was made in 1994. And so the data pump on it is a Rockwell RC288 DPI. So the same chip as the one we saw on the last modem, but this one just doesn't have voice capability, but it's still 28.8K and 14.4K fax. However, because of the age of this modem, I am not automatically convinced that this is a V.34 modem. This might be a V. Fast class modem. Rockwell states in the datasheet that this chip is both V. Fast class, which Rockwell supported in general, V. Fast class and V.34 compatible, but who knows if Rockwell made later revisions to the chip that that just aren't reflected in the datasheet. So maybe this is V.34. But it could just be V. Fast class, but we'll find out when we hook it up to the computer. And this does not have the complementary Rockwell controller chip like in the last modem. It's got this little controller chip here with a logo on it that I do not recognize. The controller chip is what basically gives the modem its smarts. The data pump chip is what generates all the screechy noises on the phone line and, you know, takes in the data and sends data. And then the controller chip is what actually gives the modem the human interface part of it. So the Hayes compatibility, the Hayes command set, the ability for the modem to communicate with a Windows PC to say what kind of modem it is, stuff like that. So we've got something weird and different here, which is kind of interesting. Also kind of neat, and a reflection of the age of this modem, it's got dip switches that are accessible on the outside, and it gives you a little legend of, it's basically what COM port you're setting, so that's kind of nice. And unlike the last modem, which I can only assume has a UART built into the Rockwell controller chip, this modem actually has a discrete UART chip on it. There's a 16550 UART on there, so high performance UART. So let's see how this guy performs. All right, we've got this card installed. This card is also an old school non-plug and play card. So once after making sure that the dip switches on this card were set reasonable, this should also just show up just like a serial modem in Bananacom. So I will run a find command. All right. And it found it. Once again, it wants a 57,600 baud serial, not serial port connection, but bus connection to the modem. I mean, it is a serial port. The modem literally has some implementation of a UART on it. But why doesn't it want a faster speed? I'm not sure. That's very interesting to me. Anyway, this modem works. So run through the ATIs here. Oh, we're getting a little more information. Shows the chip, fax class 1 and class 2. ATI 5 says the same thing. And ATI 6. You know what? I'm starting to think that this modem's just been programmed to display the same stuff for anything past ATI, whatever that first number was. What if I do this? Yep. It does not have that many ATI commands. It's just been programmed to respond to oops. Any ATI command starting with, wow, 4. ATI 4 or higher, it says the same thing. And that's just for software compatibility. But the fact that there's only 4 unique information pages, that kind of sucks. I have a feeling that's going to be a running theme in this video. But anyway, so once again, unless it just doesn't list an onboard phone book, I'm going to assume there is no onboard phone book. I will do a reset just to make sure that it's back to the default settings. And I'll store those settings, and I will do a hardware reset. And let's call the courier. Oh, that is quite a loud buzzer. Oh my god. Oh, I aborted that. That was obscenely loud. Like, like my landlady upstairs could hear that. I'm gonna turn my recorder down a little bit more. That was violently loud. So I'm gonna do an ATL1, and let's do that again. Okay, it did not store the phone number that it last dialed. That's interesting. Also, the buzzer sounds just as loud. And can you not? Oh, interesting. You can backspace back to AT, and then it doesn't let you backspace anymore. That's actually kind of nifty. That's very unique. I'm like, I wish you guys could be here in person. That buzzer was obscenely loud. So maybe I'll do ATL1, it just seemed to be the same value. Then what's ATL2? ATL2. What's that sound like if I just go off hook? Very loud. Even louder. And ETL's, okay, so actually, you know what? I could put a piece of tape over it and that'll fix it. Let's find some tape. We're off script again. I've actually left the room. Thanks to the technology of wireless microphonics, I am no longer present. I've abandoned you. And I've come back with electrical tape. I'm going to put classic trick. I've done this so many times because of my poor neurodivergent ears. Piece of tape over the piezo buzzer, and I bet it's a lot quieter now. ATM1. It is no longer responding to commands. You know what? It's because I moved the modem and I flaked out the connection to the ISA bus. Whoops. Whoops. Okay, let me just shut the computer off. Hopefully that has not harmed the computer or the modem. We're okay. All right. How loud is it now? Let me just do. Oh, it has reset. So let me just go off hook. I think that's better. Oh, it does get a little quieter with ATL1, but it seems like it doesn't. It seems like it didn't respond to ATL1 last time. Well, anyway, let's call the courier and see if it's livable now. I think it's still going to be a bit loud. What the hell? Uh... So the piezo buzzer is quieter, but it stopped handshaking right after the V.8 exchange. What the hell is it doing? It's still alive. Why didn't it finish handshaking? Oh, that's not good. It just straight up stops handshaking. Is it the courier? Is it the courier doing that? Let's hang up. Let me just power cycle the courier. This is fascinating. I have power cycled the US Robotics Courier. Let's try that again. Does it support ATDL? It does. Well, it went off hook. It didn't dial. That might be because it wasn't a successful call. It was the courier. So that it was actually the courier that was giving us grief. Okay. We connected, and this gives a Hayes compatible result code. Thank goodness. We connected at full 33.6 and V.42 error correction. Nice. It actually says V42 rather than LAPM. I like that too. Very cool. Excellent. Okay. We will hang up. Let's call the leech. Will it connect at to a Bell 103 device? Oh, let's see if it pulse dials as well. Yes, it does. That's very loud. That was obscenely loud, even with the tape. Hello? Seems to work just fine with the leech. Cool. Let me try an ATL1 again just to shut that piezo buzzer up a little bit. Okay, let's call kludge. 6.2. Once again, that was a very good handshake for the conditions. We don't, oh, there we go. We connected at 9600, V.42 bits compression. Hey, look at that. I don't think we saw that on the last modem. Oh, good. Oh. Uh-oh. Oh, I think the error correction may be kicking in hard. Waiting for those characters to echo back. Oh, this isn't good. This is painful. Oh yeah, I think we've got a lot of, I wonder if it's retraining. You know what, let me just quickly go back to command mode. Hopefully it doesn't hang up when it does that. Let's do ATM2, do ATO, and it's not retraining yet. Yeah, it's, this is very unresponsive. And that could be the board too. Maybe that Macintosh Plus is having some issues right now. No, we haven't retrained it all. Oops. Okay, that was a bit laggy, but otherwise it seemed to work okay. It never dropped the call. Next, this modem is a cool one, and in fact this may be the nicest modem that we check out tonight. This is a US Robotics Sportster. But what model of Sportster it is hard to find out, unfortunately. US Robotics made it very hard to identify their internal modems. If you look at the back of this thing, it says Sportster model 0484, and you may think, oh, model 0484, that'll tell you. Nope. If you search US Robotics Sportster 0484, you will get a few different modems. My only guess as to why US Robotics did this was so that they didn't have to test various models of modem for FCC compliance. They just tested one and then gave the rest of them the same model designation, even though they are different models, which is unfortunate. So I don't know what model of Sportster this is. However, I think this is a US Robotics Sportster Voice, which is very cool because the Sportster Voice has voicemail capability. If you look right here, that's a 512 kilobyte flash memory chip. I don't think that's where incoming messages are stored. It doesn't seem like a big enough chip to me, but it is a big enough chip to hold an outgoing message like an answering machine would have. And that's one of the capabilities that the Sportster Voice had, was an onboard mailbox. And how I've gathered that this is a Sportster Voice, aside from the fact that no ordinary modem will have a flash memory chip on it, might have like an EEPROM for firmware, but not a flash memory chip. But how I actually came across it was I first Googled this chip. And when I Googled this chip, I came up with many pictures of the serial version of the Sportster Voice, whose PCB looks strikingly similar to this. And it looks like for this, they just rotated it, took off the serial port, and stuck an XT bus connector on instead. And you get the same modem, but the internal version. So I believe this is a Sportster Voice. I already forget what the date code is on this. 3997. So it's not going to be V90 unless it was upgraded, which it could have been back in the day. But this is probably an X2 modem. X2 was US Robotics's 56K pseudo standard that they came up with while everybody was waiting for V.90 to be ratified. So this will be a V.34 modem, but with additional X2 capability, meaning that this can communicate at 56K to other US Robotics modems that support X2. US Robotics was the only modem manufacturer that supported X2. Everyone else was on board with Rockwell's K56 Flex standard. But both X2 and K56 Flex modems, for the most part, they could be upgraded to V.90 because V.90 was very similar to both pseudo standards. So, you can see this modem looks a bit different than the others we've seen so far. It's got a real dynamic speaker in there, plastic cone speaker. Very, very cool. I wouldn't expect anything less of US Robotics. This should be a hardware-based modem. I'm not going to try to test any of the fancy voicemail features, at least I won't today. If this modem works, maybe it'll be the subject of its own video in the future. But you can see here, we've got mic and speaker jacks because this modem can serve as a speakerphone. And yeah, pretty cool. So let's give it a shot, see if it works. All right, so this card's actually capable of being plug and play or non-plug and play. So I've configured it, if I remember right, I've configured it for non-plug and play. So we'll see what it does here. There we go. Perfect. All right, let's run through the commands here. So this is a US Robotics modem, so good guy US Robotics. They'll have programmed it with much more information in the ATI commands and just more helpful stuff in general. So yes, it calls it a US Robotics Sportster Voice 56,000 fax. All right, cool. And I guess I should do an AT ampersand F1. And I'll just reset it right quick. Oh, that's funny, it says baud 38.4. Is that like the default, or is that what it actually thinks it's running at right now? Not sure. We can see all the S registers. Yeah, it says we're running at 38.4. That's odd. Okay. And, no way! Okay, first of all, I didn't know Sportsters had a phone book built into them. This one apparently has a 4-number phone book, and there's phone numbers programmed into it. Wow! That's really cool. I'm going to have to obscure these. I will just clear the screen. That's really cool. So a little bit of history there. Someone actually used the phone book on this thing. That's kind of neat. And just like with a courier, we do get more technical stuff, link diagnostics. Here we go. So what have we got? We've got V.32 bis. We've got V.34 plus. So it's going to be 33.6K. And it's got X2! Oh, that's awesome! Which means we'll have to call the 2600 network. I have no idea if the 2600 network supports X2. It might or might not. But we're going to have to give them a call and see if we can get an X2 connection, 56K. 92 megahertz chip on this thing. Holy crap. And it's got a date of 1997. Very cool. All right, excellent. Well, we're all plugged into the phone system here, so let's just try and call the courier. Oops, is my phone cord plugged in the wrong thing? No, I'm plugged in the jack that says telco. Let's do that again. No dial tone. Oh dear, I can hear the speaker turned on. Of course, this modem has that big dynamic speaker. I can hear sound, but I'm not hearing the dial tone, but I'm just hearing the hiss from the speaker amplifier. Is the jack dirty? Like, here, let me go off hook and just wiggle the cord. Nothing. Just for fun, let me plug it in the phone jack. Also nothing. Oh no. Let me do something right quick. Okay, hang up. Because I can see if it's like a broken phone jack or something. If I just call the modem, it'll tell us if the line's ringing. I need a telephone to plug into. I'll just steal the courier's thing right quick. Let me just call extension 23. No, it doesn't detect ringing either. Well, just for fun, if I do ATA, what's it do? Oh, I heard it pick up. Oh my god. So it answers. Very loud speaker, but very good fidelity too. So all the sound amplification's all working. But I heard it click in the phone. I heard it pick up. But let me do that again. I just want to see if I can hear the answer tone from the modem over on the telephone set I'm using here. Let me go ATM 0 and answer. No, I hear nothing. I hear nothing on the phone. So sound, this thing is not outputting sound on the telephone line. Okay, let me try this. Let me just reset. Let me pulse dial. Let me call. I've got a telephone set plugged into an extension here, so let me just call it and see if it rings. Well, first let me see if tone dialing works, but I don't think it's going to. What extension is this? I think it's 22. Well, it just says no dial tone. I know, let me disable dial tone detection. ATW1, I think it is. No. Oh no, it's ATX. ATX1? ATX something disables dial tone detection. So the DTMF generator works, but it's not ringing. It doesn't hear the dial tone, and the Northstar system doesn't hear it. So there's just no sound into or out of the telephone jack. So let me try this. Let me pulse dial ATDP22. Yes, that works. And I've picked up the phone. And oh, it hung up. Oh no, this thing's really, like, I'm trying to think. What would cause this? So it's able to, so it is putting a load on the telephone line. So it's not a connection issue with the telephone jack. It's putting a load on the line. It's doing the equivalent of, you know, picking up the phone. And it's able to pulse dial. So the line relay is working. Unless there's multiple contacts on the line relay. I don't think so though. These relays, there's 2 relays on the card. They've only got 6 pins, so I think it's just a regular like DP-DT relay or whatever. So What would cause it? So it's not a connection problem to the telephone line. That's fascinating. Well, okay, let's try this. Let me dial again. Hello, hello. I am not hearing my voice out the speaker of the modem. I'm speaking into the phone. My voice is not coming out the modem speaker. So indeed, it's able to pick up the line, but it's not able to put any sound on the line or hear any sound on the line. So I'm trying to think, what would that be? Is it like an optocoupler gone bad or something? Could it be a bad capacitor? I doubt it. We'd have to hear something, but I hear nothing. So I'm just trying to think what the steps are to actually put sound on the line. It goes through a little transformer, and I'm assuming there might be like an optocoupler, something like that. I don't know, but it looks like something is wrong with this modem. So we are not gonna get anywhere with it today. That's too bad. This was the best modem in the whole bunch, and of course it would be bad. And the only US robotics one, too. Or no, there's 2 US robotics ones. Or I think there's 3 actually. But this is the only like hardware-based, like real US robotics modem. That's too bad. I'm gonna have to tinker with this thing someday and maybe just start replacing parts and uh, seeing if there's just like a simple bad part on this modem that's made it completely deaf. That's a shame. Next, we're into the 16-bit ISA stuff now. And this modem, another Rockwell-based one, was made in 1996. And this modem was actually made by someone that I recognize. This was made by Cardinal Technologies, which was an American company. In 1997, they were bought by Hayes Microcomputer Products, one of a few companies that Hayes bought while they were sinking and panicking and trying to find a way to save themselves. Interestingly, this has an AT&T sticker on it, so perhaps this came out of an AT&T branded computer. Was AT&T still making computers under their name in 1996? I didn't think so, but I could be wrong. Or maybe that just means something completely different. But we once again have a Rockwell RC288 DPI, so same as the last modem, 28.8K, 14.4K fax. But being from 1996, this should definitely be a V.34 modem, at least 28.8K. Maybe we'll find that it's 33.6, although it's a very early 96 date code, so it's probably just 28.8K. Got a piezo buzzer like the rest, although a bit of a chunkier one. Got a surprising number of electrolytic capacitors on here. Got the complementary Rockwell controller chip. And it's the model MVP288i2, Cardinal Technologies. So, this should once again be a standard hardware-based card, so let's stick it in the computer and see if that's true. Alright, so this is our first modem that we're trying that is a plug-and-play card. So it's still a hardware-based modem, but it's plug-and-play. And so that means depending on the computer, I may or may not be able to address this card in DOS. Now, this computer can recognize plug-and-play cards. And what that all means is that the card sets its COM address and its IRQ, or the computer sets all that stuff for the card. The card has no dip switches or jumpers for that stuff. But hopefully we can still play with this card in DOS, but let's find out. Yep, I just saw the card and I saw Cardinal MVP 288i2 or whatever it's called. And let's see if Bananacom finds it. Oh, funny, we passed the hardware check rather than getting a risky. I bet that's because it's a plug-and-play card. Yes, it found it! So the computer automatically put it on COM3, and for some reason it wants a 38.4 serial port speed? That's kind of sucky. That means even on a 33.6K connection, we might struggle to get full throughput if we have compression in use. That's funny. And it put it way up on IRQ9. Why do you only want a 38.4 connect? I'm going to try that again. It makes me wonder if maybe Procom would work better than Bananacom. I've never tried another DOS terminal emulator. Alright, it wants 38.4, we'll do 38.4. Oh, it's got a, I don't know if that's a build date or a firmware date or what, but 17 January 1996. There's the chip again. And looks like that might be it. Alright, let's call the courier. See if this piezo buzzer blows our ears out. Well, sounds good so far. Oh my god. Holy F, that was loud, too. Jiminy Christmas, what is with these? I've never heard a internal modem be so damn loud. Oh, it was set to ATI or ATL3. You know what? Something I forgot to do is just do a hardware reset. So let's go AT at F1. W, because we have no idea what settings were saved in this modem by the previous owner, right? How loud are you now? Oh, that's much quieter. Okay, let's try that. Now I can barely hear it. We connected. Oh, stupid thing. They've programmed it to report the serial port speed again. I could barely hear that. So let's hang up. We'll do an ATL2 and see if it supports redial. Yes, it does. Oh, that's loud. That was once again too loud. So if I escape, it doesn't hang up the call, which is good, and I go ATW1, and I go back to online mode. There we go. Oh, it doesn't give us the modem speed. Really? Hold on, I'm hanging up again. I'm going to go ATL1 because it's too loud. Wow. What the? It just made a VDOP 32 best connection. Why? This is a direct connection over the North Star system. That's funny. This is the first time I've observed that. The two modems decided that the connection wasn't good enough for VDOT 34. I'm very amused by that. Anyway, we got a perfect 14.4K connection. We got VDOT 42 error correction. And it must be a Rockwell thing to... No, it's not necessarily... Yeah, it could be a Rockwell thing because this modem has a Rockwell controller chip. The first one had a Rockwell controller chip, but the second one didn't have a Rockwell controller chip. So this is a Rockwell thing to report the result code in this strange format, which is kind of nice for humans, but not nice for software compatibility. Okay, I'm very interested to see how the rest of this goes. But first, I need to put a piece of tape over. I'll just shut this down. And I'm going to remove the modem and put a piece of tape over that buzzer because once again, I can't trust it to not sound like a freaking siren in here. Where was I? I guess I'm going to see if we can dial the leech now. And we'll see if it does pulse dialing. So, see what it does here. I have no idea if it dialed or not. Yes, it did. All right, and we connected, and once again we got the serial port speed. And that seems to be working okay too. Very good. Oh, it hasn't detected carrier loss yet. Hello. There is no more carrier. Wow, it's still asserting carrier detect. That's weird. Okay. Oh, there we go. That took way too long for it to detect loss of carrier. But that could be a configuration thing. I know on a high-end modem, like a US Robotics, one of the S registers, you can set how long carrier has to be lost for before it accepts that the carrier is lost. All right, let's go. 3, 1, 2. It's funny how different the volume is depending on what it's doing. Like, I can't hear it dial out at all, but when the remote modem picks up, it's loud. I can't hear the line ringing. I don't know if you heard that, how well you heard that handshake. It was slightly strained, but other than that, it was okay. I would like to know what our phone line speed is. So I'll go ATW1, ATO. Oh, of course it won't tell me, because for some reason it doesn't report the carrier speed anymore. But anyway, we're on Kluge, have no idea how fast we're connected. Let's just log in here. That is not my username. It seems to be responding okay. Will this tell me my login? Apparently 9600. So it's consistent with the others at least. All right, well that seems to be working too. And I think I'll leave the test there. So, oh, any Any quality of life features? No. Can I even read a register? Yes, I can. Yeah, so there are registers, and we can probably find them in the data sheet, but it won't define them for us in a terminal. It's just not something that every man would have ever wanted to know. If you were a power user, you know, you wanted a modem that could give you that stuff. But if you were just Joe Blow looking to get on CompuServe or your favorite local BBS or whatever, you weren't going to be concerned with whether or not the modem would tell you what the S registers were. You were just never going to deal with that stuff. So, as far as call quality is concerned and the ability to make connections, this modem passes the test. Next, another Rockwell-based card. This one's a bit newer. It's from 1999. And this card's kind of cool because it was made by Compaq Computer Corporation. Or at least they put their name on it, but it's the only name on it. This came out of a Compaq PC, and according to what it says on the back, it was made in the USA. And there you go. And it's funny, I looked up the Compaq part number on eBay, and there's a seller on eBay who has what appears to be a few dozen of these brand new in the Compaq packaging, like that Compaq had packaged for spare parts. And you can buy a brand new Compaq modem for 20 bucks. That's what they're asking, 20 bucks each. So 1999, this is going to be a V.90 modem, being a Rockwell chip. It'll also support K56 Flex, which was Rockwell's interim non-standard implementation of 56K while the modem manufacturers were waiting for V90 to be ratified. It's got a little tiny Rockwell controller chip on it, so this should still be a standard hardware based modem. And it's got a piezo buzzer on it. And the chip on this is the RCVDL56ACFW. So let's shove this in and see how it works. Well, 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 I would say this modem is dead. Bananacom does not detect it, and I can hear a very faint, weird little squeaking, buzzing noise from the piezo buzzer, so it's definitely not working correctly. It's also not detected in the BIOS during the scan of the plug-and-play devices, so I would say this modem is just not working. I've tried reseating it, and yeah, it's just not having a good time. So maybe this is one just to look at for fun someday on my own time. Maybe reflow some solder connections, see if it's that. But our testing here has hit a wall for this. So on to the next one. Next. This one's kind of interesting because it's actually a combination modem and sound card. This one was made by Aztec Technologies in Singapore. It's got an Aztec sound chip on it and, of course, our Rockwell modem on it. This was made in 1997, 16-bit ISA. No internal, no onboard transducer on it. It's got no piezo buzzer or anything to listen to the modem, but you can probably bet that plugging a speaker or headphones into the sound card part of it probably grants you the ability to listen to what the modem's doing while you're dialing as well. The modem chip, it's an RCV336ACF. That's a 33.6K V.34 chip. And I'm not sure what the controller chip for the modem would be, unless the Aztec chip. See, I know this chip's doing the sound stuff because it's got an OPL logo on it, but maybe this is controlling the data pump for the modem as well. I don't know, because none of these appear to be a UART. So, I don't know. Maybe that's what's going on. But anyway, it's a nice looking board. Made in Indonesia. So I'm assuming this will be a hardware-based modem, but maybe it won't be. Let's stick it in and find out. Well, I wasn't sure if this modem was going to work in DOS or not, because it's not only a plug-and-play card, but it's part of a sound card. But yeah, it plays nicely with DOS just fine, at least when used on a computer whose BIOS supports plug-and-play cards. So, excellent. So we'll start with the ATI commands here. Curious to see how it identifies itself. Oops. So it does say v.34. So there we go, RCV336, the Rockwell chip. And I would say that's probably it. Alright, so this modem also doesn't have an onboard sounder at all, so I've actually got the sound recorder plugged directly into the telephone line here. So let's start by calling the courier. And there we go. And I see it says connect 38400, so it's once again reporting the DCE to DTE speed rather than the DCE DCE speed. So I'll hang up here. And if I go ATW1 and redial, and there we go, Courier 336, protocol LAPM, so that's v.42 error correction. And then it reports it's funny, it reports connect 38400, but Bananacom itself is reporting a serial port speed, or rather a DCE DTE speed of 57600. So not sure why that disconnect or not sure why there's a disconnect in what's being reported. It could be a Bananacom issue. So we will hang up again. And let's try connecting to the leech, and we'll see if it pulse dials. It's got a real relay. And there we go. Carrier 300, protocol none. There. No problem at all. There we go. Alright, let's call the Kluge BBS. And there we go. Slightly strained handshake, but not bad for the conditions. And I would say that is doing just fine. So this modem gets a pass, unsurprisingly. Next, oh boy, we're on to the soft modems now. But this is probably the best soft modem that we'll be looking at tonight. That's right, it's all downhill from here. This is also our only ISA soft modem. You wouldn't know it by looking at it. Well, you might know it if you noticed the 3Com logo there. But this is a US Robotics Sportster Winmodem. However, this one is not a retail one that would have been sold in a store. This came out of a computer. And I forget which of the numbers on this sticker or possibly on the back I googled to figure it out, but I determined that apparently this card came out of a Dell computer. Now, because it's a soft modem, I'm going to need to install a driver to make this thing work. And I could possibly find that driver on Dell's website if I just look up a random Dimension or whatever computer from 1998. However, good guy US Robotics, now their website presently has broken links. But if you use the Wayback Machine, US Robotics does have drivers for this modem on their website, and apparently drivers only ever existed for Windows 95, 98, and possibly Windows NT, but it says the Windows NT only works for certain revisions, of which this is not one of them, so it might just be Windows 95, 98 that works with this. And of course, newer versions of Windows might work out of the box with it. But yeah, it's a weird looking guy. You can see this L-shaped PCB. It's got the big dynamic speaker with the plastic cone, which is nice to see. Not a single Texas Instruments chip on this, even though that was what US Robotics, that's who US Robotics used to build all of their modems. But of course, this is a soft modem, so the rules are completely different. But this has an Analog Devices chip on it. Date code late 1998. So this is going to be a V90 modem. And it's kind of funny. You might notice that the card edge connector here, it's almost got this burnt look to it. And when I first got this modem, I did take some fine sandpaper and I tried shining it up because the contacts here were just black. It's very, very weird. It almost looks like charred. I'm not sure how the contacts got like this. Maybe it was just moisture, even though all the metal parts are totally fine. So like the last US Robotics modem we looked at, this one has that weird FCC 4-digit model number, model 0706, but again, that really doesn't tell you anything. You really got to Google, really once you Google like the numbers here, like the key numbers on this sticker are 325683. So 5683 is, I believe, the model designation that US Robotics use for all of their like 56K internal soft modems. And then I think it's either the 80 or the 32 that says that this was made for Dell. I don't remember, but if you search US Robotics 325683, you'll find a website with some information, but then links to the drivers will be broken. Now, if you copy those URLs and go to the Wayback Machine, you can go to a version of the website from 2021 where you can download those drivers. So, I'm going to give that a shot. Let's shove it in the computer and see how our first soft modem performs. I'm pretty sure we're not going to be able to do this in DOS anymore, but just for fun, let's see what it does. Oh, it detected it. It said US Robotics 56K Win internal, so it is a Win modem for sure. But just for fun, let's see what Bananacom does. No per doodle. Okay, we are finally going into Windows land for the first time in this video. I don't suppose I'll be lucky enough to that Windows 95 of all things will have a built-in driver for this. But I know where I should be able to get a driver if I need one. Oh, I don't have a mouse plugged into this. Oops-a-daisies. I need a serial mouse. Okay, serial mouse incoming. There we go. Anything? Are we going to be lucky enough to at least get a new hardware wizard? Or have I used this modem in this computer before? Even my sound card's not happy. Okay, there it is. Perfect. So yeah, driver's not installed. Okay, I need to find a driver. So I'll do that, and then we'll come back. All right, I'm back, and if you can't tell by the sudden change of operating system, this turned into a bit of a to-do getting this modem working. We're still on the same computer, but the hard drive decided to die in the middle of all this. As a reminder, we're on my Socket 7 machine. The hard drive's actually been ailing for years. Well, it finally got to a point where it corrupted the Windows installation. And I thought, well, as long as I have to stick a new hard drive in here, and I've got to reinstall the OS, I might as well temporarily install something newer that might make my job easier getting all these soft modems working. So we're running Windows Millennium Edition right now, but I did temporarily install Windows 2000, and from installing Windows 2000 and now playing with this modem on Windows ME, I've learned just how uncanny soft modems are. I mean, I already knew they were uncanny, but it's just so funny. So for example, Windows 2000 has a built-in driver for this modem. It doesn't know it. When it detects this modem, it doesn't know what it is. And if you automatically search for drivers, it doesn't find anything. But if you say choose a driver manually, and you go to I think it's 3COM. You have to say 3COM for the manufacturer. And then the driver is called US Robotics Winmodem ADI. ADI, I figured, and I was correct, means analog devices, the manufacturer of the DSP chip on this modem. So I installed that driver and this modem worked with it. But it identified itself and only functioned as a V.34 33.6K modem. And it's funny because you'd run through the ATI commands and, you know, it wouldn't say anything about being a 56K modem, even though I know just by pure virtue of this modem having been made in 1998 or 99, that it should have at least X2 and probably also V.90. But this modem it completely identified as a V.34 modem. And I wanted to try installing, I did find the official US Robotics driver, but it doesn't work on 2000. It's meant for only 95 and 98. So I installed Windows ME, which we're running now, and the official US Robotics driver works fine. And with that driver installed, this modem has suddenly identified as a V.90 modem. And that's because it's all in the driver. The only hardware on this modem is the DSP chip, the chip that makes all the screaming noises. Other than that, it has zero intelligence. There's nothing. It's a completely brain-dead piece of hardware. And it's just the driver, the software, that's giving it life. And so, because I now have a different driver installed than I did running Windows 2000, it's suddenly, literally, an entirely different modem. All the ATI commands are different. The modem behaves differently. Like when I used the Windows 2000 driver and made a call with it, it emitted the data calling tone, which is, if you've ever used a newer modem, it's a 1300 hertz tone that just beeps periodically until the remote modem answers. It's the same things fax machines do, but it's a higher frequency. And it's just a nice way for a modem to say, I'm a data modem, or this is a data call, not a fax call. So with that Windows 2000 driver, this modem was making that tone. But with this driver that I have installed now, it suddenly doesn't make that tone. It's behaving completely differently. And the results of the ATI commands are different. It behaves like a completely different modem based on the driver you're using. And it goes even deeper that, like, when I'm typing commands in here, I'm not speaking to the hardware. I'm just speaking to a .dll file or a .inf or whatever. And it's just uncanny to me. For example, let's just run through the ATI commands here. Oops. So ATI 3, US Robotics, 56K, Win, INT, and then a revision number, which is going to be probably the version number of the driver. And when I ran ATI 3 on Windows 2000, it said US Robotics 33.6 Win INT or whatever. Now, when I get here, now, despite being a Win modem, this is still a US Robotics modem. It gives you a lot of power to make the modem work as well as you want, which is very nice. So, ATI 4 gives us our S registers. It's behaving just like a Sportster. It's got all the feature set that a Sportster has, which is really nice. And we go ATI 5, and look at that. This has an onboard phone book. Or, should I say, this feigns having an onboard phone book. In reality, those 4 phone number slots you see there, they're not stored on the hardware. They're just stored on a file on the computer's hard drive, and it's just pretending that it's stored on the hardware. And as a matter of fact, when I stored these 3 numbers, every time I stored a number, the hard drive suddenly came to life and started writing data somewhere. It was writing that phone number to, once again, a DLL file or an INF or something. It's all just stored on the computer. The driver is doing all the work. And the computer's hard drive is storing the data rather than static RAM on the modem or whatever. And the computer's microprocessor is doing all the work of telling the DSP chip on the modem what to do. Whereas in all the modems we've seen up to this point, the modem has its own microcontroller and associated hardware telling the DSP chip what to do. It's very uncanny. Now, in preparation for this part of the video, I'm actually taping this a few days later now. I have been playing with this modem. And it actually works surprisingly well. And I would dare say, in the grand scheme of Win modems, I wouldn't be surprised if this is one of the best ones. So let's run through the motions here. Let's call the courier right off the bat. 22. And yeah, we got a good 33.6 connection. We got V.42 error correction. And yeah, it works just fine there. Now, what about calling a Bell 103 modem? I wouldn't have been surprised if you know, the driver controlling this thing just doesn't work properly for calling an ancient modem, but let's see how it does. And notice that the dynamic speaker on this, it sounds really good. It's very nice. ATL commands do not work, surprisingly. To adjust the volume, I actually have to go to the control panel, and go into modems and properties, and there I have to install or adjust the volume this way. And you can see your serial port speed there too. I doubt that this modem is imitating a UART. I would say it's probably just the driver that's making Windows think that this modem's on a UART, its own internal serial port. It's probably not that way. It's probably, you know, directly connected to the ISA bus. Let's call the leech. Actually, before I do that, let's actually pulse dial the leech. Pulse dialing works too. It's even got a relay. There we go. There we go. It attempted a 1200 or 2400 connection at first, but then it got it. There we go. And now the question becomes is, you know, this modem seems to be working just as well as a hardware modem right now, but how well would it work if this computer, if the CPU was tied up? We should actually try that, maybe. Yeah, we get a bit of junk when the leech hangs up, so it's not perfect for sure. I almost want to stick Prime 95 on here and get the CPU loaded down and see if that makes the modem struggle. Because the modem depends on, you know, a modem is a hard real-time system, which means that everything has to be perfect. All the beeps and boops and screams and other sounds that a modem makes have to be done at exactly the right time, or the whole system will fail and the call will be dropped. And so that's the issue with Winmodems, is if the computer gets tied up doing the rest of the stuff it's doing, the driver could be late in commanding the DSP chip to make a certain noise or whatever, and the whole thing will fall on its face. Let's call Kluge BBS. Oh, I need to 62. And there we go. That's not bad for, we're running inside the North Star system. And I actually wrote a post on Kluge about using this modem. There we go. All right, let's see if this thing can achieve a 56K connection. Should be able to connect at either V.90 or X2. These are numbers I discovered. I looked at an old list of dial-up numbers, and it was a list of like 15 numbers, and these three are the only ones still running. I don't know if they're an ISP or what, but these will handshake at 56K. So if I go ATDS0, that should call the number stored in number 0. Oh, oops. I didn't add the 62 to that. Well, let's call number 1, ATDS1. So that wasn't, we fell back to V.34. We got a 31.2K connection, but that wasn't a fair test because we're inside the North Star system. So let me just rearrange it here and we'll connect directly to the line. But we got the bongs, we got the digital impairment learning sequence, which is impressive that we got that far from being inside the North Star system, where the call is being converted from analog to digital to analog to digital to analog, which just makes it impossible for 56K to ever work. But we got that far, which is really impressive. This got way farther than that courier modem that I had got. I need to, I'll just do this. 800, 350, 6885. Dial a lot faster. I'm not going through the pulse dialing on the North Star. Oh, it hung right up. What? Oh, that's not fair. A couple of days ago, I called these numbers, and I was very impressed at how it just quite effortlessly handshaked. And I got a 56K connection, but maybe not. Maybe it's being a bit iffy today. But that's all right. But on the whole, like it got as far, and I'm pretty sure farther than that courier modem did. So yeah, and I was actually on a call with the Kluge BBS with this modem to write that post. I was on a call for like 15 minutes, and it went fine. So yeah, I'm actually quite impressed with the performance of this modem. Well, that's our first Winmodem down, and it seems to perform okay. Okay, we are on to the PCI modems now, and for our first one, it's kind of funny because this is basically the PCI version of the first modem we tested, that 8-bit ISA modem made by ASCII Computer Corporation. This modem was also made by ASCII Computer Corporation. And you can see it's a Rockwell-based modem. This is a hardware modem, which is kind of nice. 1999, so this is going to be a V.90 unit. And that's really all there is to it. That 1456 VQH, that's the ASCII model of the unit. And it's kind of funny, you know, well, first of all, this should be a piezo buzzer, but it looks like someone, I mean, it almost looks like it got like sliced off, or I think it just got like snapped off somehow. And so that's not present anymore. I assume that's whatever I'm looking at is not going to make sound. And then second of all, we're going to have to actually repair this thing before we put it in the computer, because if you look at that, that ain't right. And down there, you can see the solder joint's actually broken. And if we look over here, that leg on the other side is also broken. So I'm going to have to fix that. The quartz crystal is the, I think it's the tallest component on the entire thing. So obviously in storage, this got bumped around and it got slammed and broke those solder joints. So I'll give this thing a repair, then we'll stick it on the computer and see if it survived. All right, this is exciting. I'm pretty sure this is a hardware-based modem just because it has two chips on it, two big chips. And this should be a 56K modem. And hopefully this works. It'll be the first time that we've heard a digital impairment learning sequence. Oops, I got a floppy in my drive. This will be the first DIL that's not the US robotics bong that we'll hear tonight, and on this channel in general, actually. And I've actually never heard one in person anymore, I don't think. Before, rather, I meant to say. I don't think I've heard one before. So this will be cool. And this modem has... Oh yeah, this one's got the broken sounder. I taped the intros for all these cards before I taped. I taped the intro for all the modems all at the same time before I'm actually getting to testing them on the computer, so I forget the nuances of each card. But this one's got the broken sounder, so I might have to plug you into the telephone line again. Windows has found the following new hardware. Oh really? Is it not just going to show up as a standard modem? Ah, really? Do you really need a driver for this? Wow, I need to actually, either that or this modem's actually broken, but I assume it isn't because Windows detected it. But I'm surprised it doesn't just show up as a serial port. Maybe PCI modems inherently can't do that. Maybe all PCI modems need drivers, even if they're hardware modems. Well, holy smokes, I guess I'm going to be tracking down a driver for this thing. Oh dear, back when I figured that out. Alright, well, to my surprise, the very first driver I tried worked. I couldn't find a driver for the exact model, the 1456 VQH-R. The driver I found was for the 1456 VQH-R1, which maybe that means the same thing. Maybe this is the R1, but this driver seems to work. The modem calls itself a connexent modem with this driver, and it's important to note that Rockwell's telephony products spun off to become connexent. That's where connexent came from. So it calls itself a connexent HCF PCI modem. And so I cannot be sure if this is a hardware modem. I can only assume that it is. I tested it and it does seem to work. The sounder on the modem, that piezo buzzer, it is indeed completely non-functional because most of it's not there anymore. So I've got you plumbed directly into the telephone line. So let's start by just calling the courier. and it works. And it annoyingly calls itself, or it annoyingly reports a connection speed of 115.200. That's obviously the serial port speed. And I want to fix that because that's a stupid way to use the result codes. It's just a Rockwell thing apparently. And I always forget what it is. Is it ATW1? And if we try that again, does it support ATDL? Yes, it does. And yeah, there we go. Oh, this is weird. MCR V.34, MRR 33600, 33600, ER LAPM, which ER obviously means error correction. I'm not sure what MCR and MRR would stand for, but it gives us the information we need. You know what? We're going to dial onto the internet for the first time tonight. We're on a Windows PC. I've already got dial-up world set up here. And let's see what Windows says our speed is when we call here. Oh, whoops. Let's try that again. Am I using the right modem? Oh, it's not letting me choose either way. Oh yeah, I gotta choose this. Oh, I forgot to call the leech, but we'll try that too. I'm very curious if Windows actually treats this like maybe I'm wrong. Maybe Windows doesn't directly read the result code. Oh wow. That was a little bit strained. Ah, it had fallen back to V.32, but it timed out just in time. That's not a good showing. Cancel. Let me see if I can force it down. That's not a good showing right off the bat. Let's force it down to 19.2. I wonder if that'll make it force V.32 bis. I love Mike Dank's city ringback tone. It's still doing a V.34 handshake, but let's just see what it does here. Alright, I'm going to kill this. Actually, I just figured if I slow down the serial port, I'm not going to be able to see if my hypothesis about how Windows reports the connection speed will work. So let me do this. Let me put this back to where it normally is. And I'll get off the, let's give this thing a fighting chance. I'll get off the North Star system here. I'll plumb straight into the line here. and I'm going to modify my number. Okay. Okay, cool. It went straight for V.32 bis, I assume, or V.32. I have a hypothesis as to why it did that. The answer tone, at least listening through my recorder here that's recording the telephone line, the answer tone sounds very distorted. And if the modem is hearing it distorted like I'm hearing it distorted, it's probably not picking up the 20 hertz amplitude modulation in the answer tone that's telling it that it's a V.34 modem. So it thinks it's a V.32 bis modem. But we got on the internet. And what's it say? Okay, it does say 14.4. Yeah, because my serial port's running at the top speed, so... Okay, Windows is doing something different. It's... Oh, the call just dropped. The call just dropped. Wow, this modem is not performing very well. That's fascinating. I thought this modem would perform just fine. I'm pretty sure it's a hardware-based modem. Wow, the call just straight up dropped. Okay, we'll stay directly connected to the line. And let's get back into our terminal emulator. So we'll call... I really hope this works. I really want to hear the Rockwell/Connexent DIL tone. Cool. I'm surprised how well that worked. Oh, I'm listening to the line. Yeah. Okay, we had a retrain there. So first of all, at the very beginning, before the answer tone, you heard this little chirping back and forth between the modems. Oh, and it just hung up. It couldn't sustain it. That was V.8 bis, which was a follow-up to V.8 that defined a new way for modems to list their capabilities to each other. So V.8, which modems started using beginning with V.34, it's a little 300 baud exchange between the modems where they list their capabilities. What modulations are they capable of? What error correction and compression methods are they capable of? Stuff like that. That's all explained during V.8, and then the modems know, the modems can decide on the best way to communicate with each other based on each of their capabilities. So V.8 bis, I would assume, was supposed to replace V.8, and it's that little chirping before the answer tone is even played by the remote modem. They just immediately chirp back and forth a little bit, and they do the same thing. But the weird thing is, one of the capabilities of V.8 bis is for the modems to tell each other that they support v.8. And so once two modems tell each other using v.8 BIS that they support v.8, they just decide to use v.8 instead, which is very weird. I feel like that doesn't make sense and defeated the whole point of v.8 BIS. But anyway, the US robotics modems and a lot of 56K modems, they don't do v.8 BIS. Most dial-up access equipment does support v.8 BIS, but only some 56K analog modems make use of it. And this modem's one of them. And the Rockwells and the Connexons, I think usually do support v.8 BIS. You'll only ever hear v.8 BIS on a 56K connection. It doesn't apply to anything older. And you heard the digital impairment learning tone, which is also cool. Now, I believe I forgot to run through the ATI commands. I'm getting ahead of myself here. So there it says Connexon HCF v.90 56K. I believe this supports K56 Flex. Yeah. October 6, 1999 is the date on something. And there we go. All right, I'm gonna put us back on a North Star extension. And let's see if this thing will talk to the leech without any issues. And we'll see if it pulse dials. I don't hear a relay on this modem. So it's either using a solid state switch or it's using one of those like electromagnetic things that are silent. Yeah, it'll pulse dial. There we go. I almost thought it wasn't going to do it. There we go. Perfect. No problem at all. Let's call... We haven't called Kluge yet, have we? No, we haven't. Let's call Kluge. Oops. I forgot I'm not directly connected to the line. Actually, I didn't even do an AT-AT F1. I forget, I didn't check. I didn't see in case there were any custom settings saved, but so far it's acting like there isn't. Bit of a flaky handshake, but it seems to have done it. We connected in 9600. That seems to be the norm for Kluge these days. Whoa. Oh, it's locally echoing. You are not allowed to see this. And yeah, this seems to be working okay. It's too bad the 2600 network's down, but I would say this modem passes the test. Do we have any quality of life features? No, we do not. It will not tell us a definition of registers or anything. We'd have to look up the data sheet for that chip. So there we go. This all seems to work okay. I think this modem gets a pass. Next, this modem was made by Lucent. Lucent made a lot of modems. Fun fact, Lucent was actually spun off of AT&T. AT&T was actually at one point in time a big player in the dial-up modem business. Actually, they created several modem modulation schemes, two of which, Bell 103 and Bell 212A, became giant modem standards that endured for years and even decades. But they spun off that business into Lucent in, I think, the late 90s. So this card, as far as I can find from my research, was actually made by Lucent themselves. It's not just a Lucent chipset that another company stuck on a board. And the model of the card is CW56LU-PCI. And it was made, I've forgotten already, it looks like probably 1998. At least that's the date on the chip. I don't see anything newer printed on the PCB itself. So let's stick this guy in, see if it works and how it works. Well, here we are on the IBM NetVista, and the reason that I moved to this computer was because this modem didn't want to play nice with the Socket 7 system. When I first tried to use it on the Socket 7 system in Windows ME, the modem did something so egregious that it made the computer hard reset. And I don't mean like it blue screened or anything. It was just, it was working fine, and then suddenly the screen went black, and then the computer was posting again. So it did something so naughty that it upset the computer at a hardware level, or at least a BIOS level. And so I reinstalled Windows 2000 on that computer, and Windows 2000 wouldn't play ball with it either. It reported that the modem was, not able to get the system resources that it needed. So, for some sort of IRQ issue or something. So I moved to the IBM NetVista, where the modem appears to be working fine, but unfortunately, this modem is broken. I would say the relay, it's got one of those electromagnetic read relays on it. And I would say that relay has gone bad, because this is another case where, and it won't locally echo my characters for some reason, but when I go off hook, I can hear the little piezo buzzer of the modem turn on and start hissing, but there's no load on the phone line. And when I have a telephone set connected to the phone jack, the loop-through jack on the modem, I can't hear anything. Well, first of all, that jack, at least on the modems I've used, should be cut off when the modem's off hook. It should cut connection to the phone jack. And it's not doing that. But also, when I go on and off hook and I'm listening through the phone, I just hear a steady dial tone. I don't hear anything else go on the line. So I would say the relay is broken on this modem, and it is not able to go off hook. Now, if I do an ATA and put it into answer mode, it will, and I've previously typed ATX1 to disable dial tone detection, but if I put it into answer mode, it does attempt to answer. So there's that. And if I try to dial, and I can pulse dial, and I've tried pulse dialing like a bunch of zeros to see if like the relay is just dirty and needs to clean itself. But it hasn't helped, and I don't hear, even though it's an electromagnetic read relay, you should be able to hear them make a really quiet ticking sound, and I don't hear anything. So that relay either is very quiet or the actual electromagnet has gone bad and it's not actuating at all anymore. Or maybe whatever drives the relay, a transistor or something, has gone bad. But if I just make it attempt to dial out here, once again, there's no dial tone. And what you're hearing now, that is the data calling tone that some newer modems use for some reason. It's not clear to me why they do this. It's like, supposedly the whole point of the data calling tone is to let the remote modem know that it's a data call and not a fax call, but fax machines already have a fax tone, so why do you need a data tone? By virtue of not emitting a fax tone, the remote modem should know it's a data call. I don't know, but this modem does it. So I'll hang up here. So yeah, we're not going to be making any calls with this modem, unfortunately. And the other funny thing is, slightly disappointing, this is a Winmodem. I thought for sure it'd be a hardware modem, but there it is. It's called a Lucent LT Winmodem. So I guess just like that Rockwell / Conexant modem we tried previously, having 2 chips on the card is not indicative of it being a hardware modem necessarily. But anyway, looks like this modem's bad. I mean, I could like change out that relay and see if it fixes it. It's not worth my time. It's a crappy soft modem. I'm just gonna send it to e-waste. So, oh well, on to the next one. Next, we've got another US robotics modem. Soft modem. I'm finding even less information about this than I am about that first US robotics soft modem, the one with the L-shaped PCB. This one was made in 1999, so it's a VDON90. And yeah, it's clearly, even though it's a 3Com chip, 3Com bought US Robotics back in the late 90s, and then they actually spun them back off as their own company later in the 2000s. Even though this chip has a 3Com logo in it, you can see the part number starts with AD. This is an Analog Devices chip, just like the chip on that last Winmodem. So yeah, I've looked up the numbers on this. The FCC model is 0637. It's got a sticker on here. It says manufactured by US Robotics for OEM / integration use only. Warranty and technical support are the sole responsibility of the PC manufacturer. Wow, totally washing their hands of this thing. But yeah, there's that number on the back, and then there's the product number 662974-81. When I googled these numbers, the only thing I could find was a forum post from 2001 where someone was looking for drivers for this card, and someone actually pointed them to US Robotics' Modem Identification Wizard, which is a program that it looks like you can still download from their website. I downloaded it to my phone right quick, and it did download. So if I have to, maybe I'll try that out. But we will see if this thing will detect it all. I assume Windows 95 is not going to have a driver for it. I can try that Modem Identification Wizard. If I dig some more and find the OEM, I could get it from their website if it's someone like Good Guy Dell who still has all their old drivers on their website. Other than that, I don't know, we might have to stick this in a newer machine to see if it works. And you know, it's kind of blasphemous. Look at this. They've got this great big area marked on the PCB for one of those big dynamic speakers, and they stuck a little piezo buzzer there instead. For shame. Anyway, let's see if this guy does anything. Alright, well this modem seems to be alive right off the bat, automatically installed. Windows 2000 is calling it a 3-COM Windows Modem PCI ADI. So evidently this is once again a rebranded Analog Devices chip. And this should definitely be a 56K card, but I'm wondering if it's only going to be 33.6K capability just because of the driver that it's using. We may have to hunt down the actual driver, but let's run through the ATIs and find out. So once again, it's uncannily, we're not talking to hardware right now, we're only talking to a driver. No, it's a 56K driver, okay. It calls itself US Robotics 56K Win INT. All right, perfect. Oh, and look at that, even though it's a Winmodem, the US Robotics, they put some work into the driver to make it act like a feature-rich hardware sports modem, basically, is what this should be equivalent to, is a regular sports modem. Sportster is what I meant to say. Okay. And nothing is stored in the phone number memory because nothing's actually stored in the hardware on the card. It's just all in the driver. Cool. We get all the diagnostic stuff. Okay, perfect. So this driver is evidently the proper one. It says it's got V.32 bits, V.34 plus, X2, and V90. Perfect. 34 megahertz is the DSP clock frequency. And the driver's got a date of 1999. Blacklist numbers. Oh, interesting. It's the first time I've seen something like that. Okay, cool. Well, let's get right to it. Let me go off hook, see how loud the buzzer is. I am hearing nothing. That's not a good start. Do I have my phone line plugged in? Yes, I do. Let's just try dialing. Oh no, it's okay, it's just super quiet. However, it is not ringing the line. Okay, let's do this. ATL2. Oh, interesting. ATL2. There we go. So we got a dial tone now. It's a couple of days later again, and I'm actually the only one in the building tonight, so I can be loud with no consequences. So we'll go all the way here. There we go. Not that that's very loud at all. Just a little piezo buzzer. Okay, let's dial out. Let's try again. Oh, you know what? My phone cord's not plugged into the modem. This modem emits a data tone. There we go, plugged in. All right, good. And we get a properly formatted result code, although it does not tell us what features we have. It just says connect 33600. And I'm pretty darn sure that we must also have some data compression or error correction functionalities. The ARQ light is lit up on the courier, so we must have ARQ. So if I hang up and it properly detects carrier loss, if I go ATW1, oh, it doesn't like that. Or is it AT? No, it's not AT ampersand W1. AT ampersand W is the save command. AT $? Oh, good old US Robotics gives you a catalog of functions. Oh, ATW is not in this thing's vocabulary at all. Well, if I go AT ampersand F1, Let's see if it'll pulse dial. Ooh, oh, it's doing its own echoing now, so I got to turn local echoing off. Now that I've done that, oh, I hate the Windows 2000 version of Hyperterminal. Makes me do this. Yeah, it's got a mechanical relay. There we go. We've got a full result code now. That's good. You can tell that the way the sound is amplified for the piezo buzzer, the one side of the phone call is amplified far more than the other side. So you don't hear the courier like during the V.8 portion of the handshake. You only hear this modem's V.8 data and not the courier's by the sounds of it. So it pulse dials. Will it call the? Will it connect at 300 baud if we call the leech? Oh, and we suddenly, hold on, I'm going to hang up here. We suddenly lost volume. Oh, I guess because I did the reset there. Let's just do an ATW, or AT ampersand W rather. There we go. And the leech is probably off hook, but I will try dialing it again. There we go. I think it's about to pick up. There we go, I think. Yes. Very good. I'm impressed. You know, I've expected at least one modem by now would not have connected to a Bell 103 device, because I know some people have tried to call the leech with their modems and they will not connect at 300 baud. They just attempt a 2400 or 1200 handshake and then they just go silent. Hang up. Oops. Oh, okay. Here we go. All right, let's call kludge. All right, very good. And that was a pretty reasonable handshake. It's funny, I always used to get really good connections on this to this BBS, but lately all I can connect at is 3600. Then again, it might just be my courier, my courier V dot everything. Maybe that's the only, the courier V dot everything is just such a solid piece of hardware that it maybe just it alone does a really good job connecting to this BBS. That works well. Click. Oh. Oh, you little devil. You didn't detect the hang-up. You don't have disconnect supervision. I think this is a first for these modems. Either that or it just didn't... there we go. That took long enough. Huh. This modem doesn't have disconnect supervision. Well, well, well. Or either that or it was just super slow kicking in. Alright, I've been told that the 2600 network, after several days, is back online. So let's just call it, we're still within the North Star system. And, oops. Uh-oh, I better... There we go. We're still within the North Star system, but we'll see what it does. And I've been told that one of their numbers evidently works a lot better for establishing a connection than their other numbers. So we'll try my usual number first, and if we don't get a successful handshake, maybe we'll try the other number. I'm interested to see, though, what does the US Robotics bong sound like through a little piezo buzzer? And I'm assuming we'll get the bong. It's a US Robotics modem. Well, we did get some bongs. It tried, but it fell back to V.34. We'll hang up here. Now, I've been told that, at least by my friend Braden, who now has the V.92 courier that I did a video on in the past, he says that the 2600 network's Washington number works better than all their other numbers. I tried all of them. I figured they were all just DIDs that all go to the same line, right? But maybe they're actually going to different lines, different equipment maybe. 564-244-2600. We'll try it. Wow. Aw. Well, it was close, but it sounds like it fell back to V.34. But still, we're inside the North Star system. So, yeah. Well, we did connect at 28.8, and that's pretty good. So we'll hang up here. I just want to see, you know, can this thing actually make a successful 56K handshake? We'll eliminate the North Star system. I'll put it directly on the line here. Oh, I just need to go, oops, AT, no, I do need to type it in. 5642244 2600. Well, well, well. You get it? Did you finish? Are you going to give me a result code? Look at that. Very impressive. I have a feeling it's not too happy though. That took an awful long time to give me that result code, and also I don't have a login screen yet. Oh, I think she's struggling. Oh, there we go. Oh, and it just hung up. Yeah. 56K is really hard on VoIP lines. Braden actually has an advantage over me. He uses a Northern Telecom Business Communication Manager, which was the successor to the Northstar. The BCM is basically all IP based, or at least closer to being IP based than a Northstar is. Northstar is just a classical, 1980s style digital but not IP based telephone system. But the BCM, one of its advantages is it has built-in ATA, so you can connect analog telephones directly to it, which is nice. And also, it can directly interface with the internet to connect to a VoIP provider directly without having to use a separate ATA like I'm doing. So it actually eliminates a conversion step. When he makes a call through his BCM, it's just going from analog to digital. It's not going from analog to digital to analog to digital. And so he's got a bit of an, I imagine he's got a bit of an advantage because the Northstars, or the BCM, is not doing that double conversion like I am. Although right now I'm not connected through the Northstar, I'm going directly to my ATA. But yeah, so hey, we actually did get a connection. It didn't hold it, but we did get it. That's very impressive. So I would say this modem passes the test too. It does everything that I would expect any decent modem to do. Very impressive. Next, this is a weird one because this modem was made by Intel. It was made in 1996, and you can see it's full of AT&T chips in it. AT&T was a reasonably sized player in the modem market. Of course, back in the day, they created the first two modem modulation standards, Bell 103 and Bell 212A. But yeah, even later, into the 90s, AT&T made modem chipsets. The main chip of interest on this is the one Intel chip on here. It's an Intel MDM28 PSVD. So this is 28.8K. Should be new enough to be V.34. You can see it's got some nice silk screening on here. No sound transducer on it at all. No audio jacks on it. And this might be an audio jack. It's not like a CD-ROM audio jack. It's only labeled JP1. But yeah, very, very interesting. Now, I seem to recall that I tested this modem once and I just couldn't get it to work. I think the computer, the card was alive, but I couldn't find a driver for it. But I would think that this ought to be just a hardware modem that would show up as a standard Hayes compatible modem. I'm not sure. So Let's stick it in a computer and find out. Well, unfortunately, I think the story with this modem's gonna be the same as when I last tried to get this modem working 3-ish years ago. Um, just nothing as a driver for it. It's kind of a fringe modem. Intel made a few different modems, but they were certainly not well known. It must be an ISA versus PCI thing, because this is definitely, you can see here, it's showing up as a quote PCI serial port. And it just must be an ISA versus PCI thing, where an ISA modem just appears to the computer as another built-in serial port on the motherboard, which has a permanently attached modem connected to it. But PCI must not allow for that, so PCI modems must always need drivers. But yeah, I found the file name of what the file name for the driver for this modem should be. It's mdm28psvd.exe or something like that. And it was supposedly for Windows 95. But I cannot find a download for that driver anywhere. Supposedly an old Sony Vaio of the time used it. I looked for drivers for that specific Vaio, and I can't find any of those. And this particular card came out of an IBM computer, and I searched a couple of random IBM like Aptivas from 1996, and I couldn't find where I could download drivers for those, or at least not modem drivers. So I think I'm just gonna have to put a pin in this one, just like I did 3 years ago. I did boot a Linux Live CD just to see if Linux would pick up on it. It did not. So I think we're just gonna have to put a pin in this and just say we cannot get it working. Next, I'm kind of excited for this card because this is the modem that I surfed the internet on between 25 years ago and 15 years ago. This is a Motorola SM56. It's a V.92 soft modem. I think it's V.92 anyway. It could be V.90, but it was made in 2000. And yeah, I pulled this card out of our Packard Bell 7955C computer before my mother basically made me toss the computer. The hard drive went bad in it. Mom said get rid of it. She wouldn't let me keep it. But I pulled the good parts off it, and that included this modem. So this is the modem that I surfed the internet on for several years. And Motorola modems are kind of interesting because they have a very strange digital impairment learning sound. So if we can hopefully get this thing to attempt a V90 or V92 connection over my VoIP telephone line, we will hear that very unique and kind of strange sounding DIL. But let's stick this modem in and see if it hopefully still works. All right, it is 2 months later, I think. This is actually the very last part of this entire video that I'm taping because I've gotten everything else done, and it was only today that I finally got this modem working. It took me so long and trying so many different things over the course of many hours to make this modem work. And today was the day that I decided to try, you know, air quotes, one more thing. And if it didn't work, this modem was going in the trash. And by golly, it worked. I tried 5 different, I think this is the 5th computer that I tried this modem on. And I tried every version of Windows from 98 to I think Windows 7. And I just could not get this modem to work. I tried a dozen different sets of drivers, even though all the different sets I downloaded, except for 1 or 2, were all the same set of identical files. Yeah, I don't know why I just couldn't get this modem working like all the rest. What would happen is it would show up in, no Windows version has a built-in driver for this modem. It would just show up as a Well, actually, on most of the computers, it was showing up as just PCI device, just a generic PCI device. But on this computer, we're on the Dell Dimension XPS D233, which I've pulled out of the basement and powered on for the first time in like 2 or 3 years today. It showed up differently on this computer. It showed up as a PCI simple communications device, which is what kind of gave me a good feeling that maybe things might go differently with this computer. But all the other computers I tried this modem on, everything from the Socket 7 system to a circa 2010 system, it would just show up as a generic PCI device and no drivers would work. Windows would, say that any kind of driver I installed that it wasn't compatible. I would tell it to install the driver anyway, and the modem just wouldn't work. But for some reason, this particular computer, it shows up as a PCI simple communications device, which is basically what Windows calls a modem that it doesn't have a driver installed for. And I tried the first set of drivers I tried didn't work, but I think it was a weird set of drivers because it didn't have a specific program called SM56helper.exe that I recognized from my childhood. But the second set of drivers I tried, which did have that program, it worked just fine, and this modem's working now. So I don't know why the heck it took the 5th computer for this modem to work. I don't know if it's a BIOS thing. I can tell you one thing, though, from I did a lot of testing with this modem just because I was so excited after 2 months to finally get it working. I've already made a bunch of calls and done a bunch of tests with it. This modem sucks. It's really, really terrible. This is a garbage modem. And it explains so clearly for me now why having dial-up internet sucked so much for us 20 years ago. We thought that it was just the way dial-up internet was. Also, my mother always figured that our phone line just kind of sucked. But what I'm realizing now today, testing this modem now, is this modem just sucked. And if we had had a decent modem, even just a cheap Rockwell modem, it would have made all the difference in the world. This is by far the worst modem that we're going to find in this entire video. And of course, the modems that we look at after this one in this video, some of them I'm going to say, wow, this is the worst one we've tested. But I taped all them before this part that I'm taping now. This modem is the worst one in the entire bunch, which is a little disappointing because this is the modem that I'm most nostalgic for. But it explains so much to me now why back in the day we could never connect to our ISP faster than 28.8K. It explains why we dealt with dropped calls a lot. This modem is just actually kind of crap. And actually, there's a website, modemsite.com. I think it's mostly just an archive of itself now. It's still up, though. On modemsite.com, there's a page on this modem from probably the early or mid-2000s, and the author of the website basically wrote, "We don't recommend you buy a Motorola SM56 modem. They're not very good." And I concur now from the tests that I'm doing with this modem today. So it's fascinating and it's very fun. And now, finally, after 2 months of trying, I would like to demonstrate this modem for you now. You know what? I think this computer, the Dell Dimension XPS D233, which, by the way, I could have swore I had 2 of those US Robotics Sportster Winmodems with the L-shaped PCB. But I only had 1 in the box of modems, you only saw 1 at the beginning of this video. Turns out the other one was actually in this computer. But I think this computer, by pure virtue that it's the only one that this Motorola modem works in, I think this computer has won this Motorola modem. I'm going to keep it in this computer purely because it's the first computer out of several that I've tried that it actually works in. So I think this modem's just going to stay in this computer. The only reason I'm not going to offload it for $1 or whatever on eBay is just because of the nostalgia. But it's a terrible modem. It's e-waste. But I'm going to keep it in this computer because it actually works now. So anyway, there it is. And here's HyperTerminal. And I'm actually going to show right down here in the system tray, it is not 3:45 in the morning. I just installed Windows 98 2nd edition on here just right quick. This computer had Windows XP on it for some reason. It's a Windows 95 era machine. I don't know why the hell I had XP on it. But I just haven't set the clock. It is it is not 3:45 in the morning. But this is the SM56 helper program. You can see that's what it's called right here. And we double click on this. And there we go. And it's got a bunch of tabs and you can set stuff. And it actually shows the status of the modem. It'll tell you right here what speed you're connected at. It'll give you a reason for the call dropping, which is actually kind of cool, although the only reason I've seen it show so far is it'll say call disconnect due to poor line quality. I would argue that it's more due to poor modem quality. But yeah, there you go. And I don't know why you need to set country and language. It does put itself on a COM port, so you know, Windows itself just addresses the modem directly because it's a plug-and-play modem. But if you had a piece of DOS software, as long as Windows is running, you can't do this in DOS itself. But if I open up a DOS window, and I could open Bananacom in here, and it would be able to address the modem. Because the driver does account for that, and it puts the modem on a virtual COM2, so you can just direct that DOS software to COM2, which is very nice. Our speaker volume choices are off and are on. We do get a bus speed selection, and we get other stuff, which is nice. This is all standard plug-and-play stuff that you'll get in Windows. Extra settings, nice. Port already open. Oh, because I have HyperTerminal open. You can choose what COM port it's on. Enable DOSBox support. Even gives you I/O and IRQ. Very, very neat. This is for the voice capabilities because this modem does have speaker and microphone jacks on it, so you can use it as a speakerphone. And I believe if I had a sound driver installed, which I don't, we could actually route the audio through the computer's own sound card using DirectX, which is cool. Same thing here. So, that's the SM56 helper. I'll actually keep it open here because you'll be able to see what it says in this little message box down here. So, we will do our usual stuff. We'll roll through the ATIs here. Oh, it gives you a reason for the last disconnect. That's very cool, actually. And I think that's it. And I looked up the manual for this modem. This modem actually has S registers. Or I should say the driver implements S registers. Of course, it's a soft modem. But there's only 18 registers, and they don't set anything like modulations or anything like that. But there is a non-standard AT command. You can actually control this modem, control what modulation it uses. You can force it to use a specific modulation, anything from Bell 103 to 56K, which is really cool. And it's AT*MM and then a number between, I think, 1 and like 12 or 1 and 11 or 0 and 11 or something like that. So very neat. All right, so I have you listening through the piezo buzzer for now. We're going to start by calling the courier as usual. And there we go, and you can actually see it says down here, connected in data mode, and the speed. We got LAPM, we got a nice Hayes compatible result code, but 24, oh, and it literally retrained. So this is just within the Northstar system. This is simulating an ideal telephone line, and we only connected at 24 kilobits per second. Huh? We definitely should have gotten 33.6. And also, I'm pretty sure we just witnessed it retrain. That's kind of awful. Either it was retraining or ARQ kicked in and it requested a packet of data to be resent, even though there's actually no data being sent between these modems. But why 24K? Like, this modem is that bad on an ideal telephone line. It connects at 24K. That's pretty awful. And it makes me think that maybe back in the day, maybe it was actually 24K that we connected at, not 28.8. Anyway, very disappointing. I'll disconnect from the originating side here, see if that works. Yes, it does. Okay, so this will connect to the leech. It will pulse dial. But I'll see if you can hear this, because there is something interesting to consider here. Done. Do you notice what was weird? What was weird was it immediately fell back to Bell 103. It did not attempt a Bell 212A or V.22 bis connection. Did not try at all. And so what that means is if I were to call a BBS or something with this thing that wanted to connect at 1200 or 2400 bit per second, it would fall back to 300 baud, which is not ideal. Why doesn't this thing try to connect at 12 or 2400? I don't know. However, if I use that AT*MM command to force Bell 212A or V.22 bis, that would work. I have tried that, and that's what I would have to do with this modem if I wanted to connect to a board that only supported up to 2400 bit per second, because at its default settings, the modem would connect at 300, so I would have to manually force it to 12 or 24. And that's not ideal, and this is the only modem of the entire bunch that has this deficiency. It's good that it connects at Bell 103. I thought that would be the deficiency that at least one of these modems would have. But on this modem, the deficiency is actually 12 or 2400. Very odd deficiency. So, let's get into the world. We're going to try Kludge BBS. And actually, let's just, I'm not even going to try this from within the Northstar system. Let's just go ahead and connect directly to the line. And, because let me tell you, it's definitely not going to work through the Northstar system. And this is actually probably not going to even work directly connected to the line. That's how bad this is. And there we go. I don't know how well you could hear that, because the piezo buzzer on this is pretty loud, so I forced it down before recording with ATL1, but it got hung up on the V.8 portion of the handshake, and that's all it'll do. I've made many attempts to kludge. It will not connect to kludge. Let me do an ATL2, and we'll connect to dial-up world. This modem will connect to dial-up world. It won't connect to Cluj, but it'll do dial-up world. And actually, let's do this proper, because I've actually set up dial-up world. Oh wow. Wow, couldn't even get past V.8 on the dial-up world. Wow, that is kind of awful. Last night I was connected to dial-up world, and actually, to this modem's credit, I was connected to dial-up world for 45 minutes. I decided to connect, and I actually started running Windows Update Restored. I started downloading Windows updates over dial-up. Calls, for me, calls to dial-up world are free because we're both on VoIP.ms as our telephone line provider. So it's a free call for me. So I just stayed connected for like 45 minutes, expecting that the call would drop at some point, but it stayed connected. It was connected at, I think, 21.6K. And I just used the internet on this thing for a while until I gave up and disconnected myself to go to bed. It was very impressive, but now today it will not connect, which is kind of nuts, but it also speaks to the rather poor quality of this modem. Back to Hyperterminal. So I've also successfully made 56K connections with this, which is very, very cool, because that's what's very nostalgic to me. Motorola modems have a very unique digital impairment learning sound. It's actually a very eerie sound. It's a little weird. And so I have never been able to make a successful 56K connection with this modem, not surprising at all, but it does get as far as the DIL. So let me demonstrate that. And I don't know, if we can't connect to Cluj and we can't connect to dial-up world, maybe we're not going to be able to connect to anything. But I'll give it a try here. Okay, that fell on its face. You heard part of the DIL. We'll see if it'll do it again here. Okay, let's give that up. You heard a tiny sliver of the DIL. You did not hear most of it. It didn't even try. Let's do that again. Wow, last night just must have been a better night than tonight is. I don't know why. Okay, I'm gonna cut that because that is just so shrill when it retrains. But you heard it. You heard the entire digital impairment learning tone, which is great. So that's what it sounds like. That was the sound of my childhood getting on the internet, and it's really, really cool that I can share that with you guys now. That took way too many attempts to get that far. This modem is really, really, really terrible. It's awful. So, I want to get you a direct connection so you can hear that DIL tone directly. Of course, the guy I've mentioned before who has a website where he's logged the DIL tones of a bunch of different kinds of modems. He has a recording of this too, but I'll share you my own recording. So let me plug you in and you can hear it directly, hopefully. It does try V.8 bis. Oh, uh-oh. Oh, what's happening? Oh my god, did we crash? I think... No way! This friggin' modem crashed the entire system! Get out of town. What a piece of junk! Oh, maybe I'll still offload this modem on eBay for $1. No way! You piece of crap! It definitely just got so confused. It got so hung up on that V.8 exchange that it didn't know what to do. And it just took down the entire building with it. Wow. Okay, I'm not gonna toy with this any further. You get the point. This is by far, by a not insignificant margin, the worst modem of this entire bunch, which it just makes it all the funnier to me that this is the one that my mother and I had to deal with 20, 25 years ago. We just didn't know. We didn't know that this was an awful modem. And frankly, you wouldn't have thought it was from a company like Motorola. Think of what Motorola was doing 20, 25 years ago, how prestigious they were as a company. You would have thought they would have made a great modem. No. All the issues we had way back in the day that we thought were due to a bad phone line or just a crappy computer or Windows 98, it was all this modem. This modem sucks. Amazing. But anyway, there you go. I'm just remembering now. I did last night. I did record some MP3s of it handshaking and executing a DIL, just in case I couldn't do it live for you here during this taping. So here's a direct recording from the phone line of it handshaking and getting as far as the DIL. Next, we've got a modem that was made by Lectron. I don't know anything about them. It's based on an Azure chipset. So the model number is I56LVP-F40. Warranty void if remove. Perfect. So, let's stick it in and see if it works. So this modem installed just fine. First driver I downloaded, installed, worked perfectly. What a freaking delight after the hell I went through with that Motorola modem. Kind of interesting. I was a little bit weirded out because Windows is calling this modem a Lucent Winmodem. But I looked it up and it turns out that Azure Systems was actually spun out of Lucent. So this this driver just must be old enough that it still refers to it as Lucent. And of course, as we've learned today, in the world of soft modems, a modem can identify as anything it wants to be. Also, I've now conceded and I've learned that having two integrated circuits does not a hardware modem make. I just assume that, you know, if a modem's got two significant looking integrated circuits on it, one of them must be a controller chip, but that's obviously not the case because this is I think the second modem we've looked at that has two chips on it but is not a hardware modem. So, okie doke. Anyway, it is working just fine. I made one test call, or I haven't made any calls with it yet, but I took it off hook just to make sure it was actually working. And the piezo buzzer on this is incredibly quiet. So depending on, I executed an ATL3 just to make it as loud as it can go, but I may end up directly connecting you to the telephone line if it's too quiet. But let's start by running through the ATI commands. And I've got no echoing, but that's okay for now. So it calls itself an LT V92 data fax modem. Cool. And I would say, okay. Oh, look at that. Oh, interesting. We've actually got some diagnostics. It's kind of a luxury on modems this new, especially soft modems, to give you information like that. Of course, it just all depends on what kind of effort they wanted to put into designing the driver, because of course we're only talking to the driver right now, we're not talking to hardware. I am just going to turn on local echoing, or actually, you know what, if I do an AT ampersand F1, I bet it'll echo now. No, it does not. So I will turn on local echoing. And let's call the courier. It's been so long getting to this point after fighting with that Motorola modem that I forget what extension the courier's on, so I'm just going to try 22. Okay, that is not the extension. Is the courier still plugged in? No, that would be the issue. Okay, let's try that again. Oh, that's weird. Why did it print ETDT? That's weird. All right, let's try this again. Wow, that piezo buzzer leaves a lot to be desired, but we did connect at 33.6K. And the result code only says V42, but the ARQ light is lit up on the courier, so I would assume they negotiated for ARQ as well. Very good, I will hang up. And it has good carrier loss detection. Let's see if it'll pulse dial and connect to a Bell 103 device. Wow, it's got a real relay. And there we go. Perfect. And funny enough, it even reports no error correction. Of course, that just doesn't exist for Bell 103, and it's not needed either. Good time. Oh, I think it just hung up. It hung up. I think I waited too long to type. Let's try that again. ATDL. There we go. Oh, what the heck? Oh, that's so gross. It's like buffering it. It's not just spitting it out in real time. Oh, that's disgusting. I think this is the first modem we've seen that does this. Ew, why are you, but just send it as it comes. Wow. I mean, you get points for connecting to a Bell 103 device, but it's so gross that it's like, it's buffering this text and spitting it out to me at chunks at a time. That's kind of dumb. But, you know, props for connecting. All right. Let's go ahead and call a BBS. It's hard for me to tell through that terrible piezo buzzer, but I think it actually fell back to V.32 or V.32 bits there, which is good behavior in this case. Now let's go ahead and try the 2600 network. Now, Azure modems, at least all the ones I've heard, they have kind of a cute DIL tone. It's a very bubbly sounding tone. We'll see if this one makes the same. And we'll also see how well it connects at 56K through my North Star system. Wow, that is rough. I think I know just from the speed, we didn't connect at any 56K modulation. That piezo buzzer's so bad, I couldn't tell if a DIL played, I couldn't tell if it fell back. It didn't sound like it even attempted a V.92 handshake, although it did, I think, at least attempt a V.90 handshake, which is a little odd because it's a V.92 modem. Let me hang up. Does an escape code work? Yes, it does. And let me just connect it directly to the line. Wow, okay. I don't know about you, I'm starting to think this modem just kind of stinks. It has not attempted a 56K connection at all, even though the driver claims that it's capable of it, and of course it is capable of it, or at least should be. I'm going to try one more number here, and then I'm just going to call it a test. Finally! Oh, I think we're retraining. I can hear it. Well, finally, we got a 56K connection. That did not sound like a V.92 handshake, so I assume we made a V.90 handshake. And it was very hard to hear if you don't know what it sounds like up front, but I did hear it do the DIL. It was very quiet under the static, but it's this blipping sound. It's like a blip 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 blip. And that was the DIL. We'll hang up and do it again. And now that I've described the sound to you, maybe you'll be able to pick it out. What is easy to pick out is the tone that the originating modem, this modem, makes to tell the remote modem to make the DIL tone that it has described to it. So you hear that tone, it's like this high-pitched tone, and then the DIL plays. So if you have a hard time hearing the DIL, you'll probably be able to hear the tone that prompts the remote modem to play the DIL immediately before the DIL plays. Let's just do that again. There you go. So finally, it took way too many tries to actually make this thing make a 56K connection, but we did it. We heard the DIL. That's actually a different DIL than other Azure modems I've heard. So obviously there were at least a couple in use. But there we go. I would say this modem just kind of stinks. It's not terrible. But that took way too many tries compared to even other soft modems that we've tested today. That took way too many tries to get a 56K handshake. So this modem is one of the weaker ones that we've tried. And the way it like buffers data and then spits it out to you at chunks at a time, even at 300 baud, that's kind of unnecessary. You know, the other Win modems we tested didn't do that. So this modem, I would say it's probably the worst one that we've tested so far. And we're not even on to the connections yet. But anyway, there we go. On to the next one. Next, this modem is made by someone I've never heard of before, Pctel. It's a Pctel model HSP56 micro modem. V90 and K56 Flex is what it says on the PCB there. 1999 date code. And I've never heard of these guys. Made in Taiwan. And yeah, know nothing about this. I'm only assuming that it must be a soft modem. So let's plug it in and see if we can make this guy work. Okay, so this one was a little bit difficult to get working, but I got her in the end. First thing I tried was Windows 2000, and I found a driver for the modem no problem, or at least what presented itself to be the correct driver. And the driver installed and Windows detected it just fine. But sometimes when I made a call, during the handshake, the computer would just hard lock up. And when it did that, the modem would just endlessly make a very strange sound. I actually got it on video here. And yeah, the computer would just freeze solid, couldn't move the mouse or anything. I had no choice but to power off the computer. And it did that a couple of times. Before I decided that something must be wrong. And the other weird thing was that that driver, the modem presented itself as a V.92 modem when it's not new enough to be a V.92 modem. But granted, the whole point of Win modems is that the capabilities of the modem are largely defined by the driver. So next I tried Windows 98, and I couldn't even install the driver on Windows 98. I found a different driver that claimed to be for Windows 98. I also tried the same driver that I used in Windows 2000, and I got the same thing both times, where the installation of the driver would crash. I would get one of those big white error boxes that Windows 98 generates that said run DLL 32 or whatever, crashed. And I tried Windows ME and I got the exact same thing. So now we're on Windows XP, and Windows XP actually has a built-in driver for this modem of all things. It doesn't for the Motorola, but it's got it for this modem, so I didn't have to do anything. And it identifies it correctly, an HSP56 micro modem. And the modem is working. I went off hook, it goes off hook. So let's run through the ATI commands and see what it says here. There we go, Pctel HSP56 micro modem. Fun fact, micro modem was a name that Hayes Microcomputer Products gave to some modems that they made in the late 70s, early 80s before the smart modem. So it's funny that 20 years later, someone made a modem using the same name. Oops. So it says V.90 here. And it's just reporting the same thing, probably by design. Oh, that's funny, huh? Anyway, we're good. So this modem does not have an onboard sounder, so I've got the sound recorder connected directly to the phone line. So let's see how this thing sounds. Call the courier first, of course. And there we go. And oh, I hate when they do this. It reports a serial speed instead of the actual modem to modem speed for the result code. So if I hang up and I go ATW1, and let's just try that again. There we go. Wow, that is also not a Hayes compatible result code, but it tells us what we need to know. For some reason it still says connect 115.200, but it does say carrier 33.6, protocol LAPM, compression none. This is a similar format to what the Rockwell modems do, so I wonder if this is going to largely behave like a Rockwell modem, and I'm most interested to see if the DIL that we'll hopefully get out of this thing is going to be a Rockwell DIL. I'll be very excited if it's a DIL I haven't heard before, because if it's one that hasn't been logged on that guy's website, I'll be excited to write him an email and send him an MP3 and be like, hey look, I found a new DIL tone. Okay. So let's see if it pulse dials and if it'll connect to the Leech CSD 5300. There we go. Perfect. So there's a minute amount of buffering happening here, but nothing like with that other modem. So this works. Perfect. All right, let's try Cluj BBS, who may or may not have blocked my number because I forgot my password. Oops. 62. All right, that worked. No problem. Well, my number hasn't been blocked at least. Hey, there we go. I remembered my password. All right, well, time to hear what this thing's DIL tone sounds like. Hopefully, I'm going to try a call from inside the North Star system. It's a good litmus test of just how tolerant the modem is. I don't know if you guys heard that. I did. That is a DIL tone that I never heard before. And I'm very excited because now I get to email this guy, send him an MP3 and say, look what I found. That's fantastic. That's a weird tone. It sounded like a mosquito flying by. That's fantastic. It did ultimately fall back to V.34. And actually, I can hear it retraining right now. Just for fun, because we're on a roll here, let me call one of the other 56K compatible numbers. Okay, so that handshake fell on its face, but we heard the DIL tone again. We also heard in the beginning it attempted V.8 bis, but it didn't finish for whatever reason. They just gave up halfway through the exchange. All right, I don't want to waste your guys' time or my own any further, so I'm grouping these all together. We're on to the 2000s vintage sludge. Or at least some of these are sludge. Some of these might not be. These ones on the left here may be the better of the sludge, although I'm pretty certain they're all going to be soft modems. And then these four on the right hand side, they're all based on the exact same Connexent chip, actually. So yeah, these are just, you know, whatever garbage. I'm probably going to have to throw them in something possibly running like Windows 7 or something for them to be detected. So, some of these have just one phone jack. They don't even have a loop-through jack to plug a telephone set into. And a lot of these don't even have transformers on them. Like, I don't understand. How are you interfacing with the telephone line, sir? I don't get it. Like, is there just a resistor keeping the motherboard from being destroyed when the phone line rings? I don't know. But anyway, we'll see what they do. Funny, this one's got this black box covering what we know is just this. Like, we know what's under here. Why is it covered? What are you protecting? Yeah, these ones on the left, they might be okay. I am interested to see how the bottom tier garbage performs too. Maybe these are perfectly competent telephone interfacing sound cards. That's pretty much what they are. But maybe they're okay at what they do. I don't know, but let's find out. Alright, so I'll start with the only Azure modem in the bunch. The rest are Connexent. Or I should say the chipset on this modem is Azure. The modem itself was actually made by Lite-On, and it's a Hewlett-Packard part. It came out of one of their computers. The driver, which I was able to find just by Googling the Lite-On model number for the modem, driver calls it an Azure Systems PCI soft modem. And we'll run through the ATIs here. Let me just do an AT ampersand F1. It seems, oh, really? Hold on a sec. AT ampersand F1. Really? This modem will not accept an AT ampersand F. Will it do an AT ampersand F0? It does. Okay, that's weird. So the difference between that is AT ampersand F0 is for initialization with software flow control, and then AT ampersand F1 is for hardware flow control, so request to send, clear to send. This modem does not accept AT ampersand F1, but it does accept AT ampersand F0. That's very strange. Now, it makes sense because it's a software modem. There really is no true, and also it's an internal modem, so there's really no distinguishing between hardware and software flow control. But for software compatibility, the fact that this thing returns error when you enter AT ampersand F1 could make some software think the modem's not running properly. They really should have programmed it or programmed this driver to just execute AT ampersand F0 when AT ampersand F1 is entered. Anyway, but I got local echoing now, which is good. Oh, look at that, a built-on date, 4/13/2004. But is that the actual modem date, or is that the date of the driver? Now I've got to check. 4/13/04, yeah. So it's not the modem was built on, it's the driver was signed on or whatever. But the modem itself is from 2004, if I remember right. Perlite. I have no idea what that is, unless that's Lite-On's brand name for their modems. There it is again. Oh, look at this. What's this? Oh, connection diagnostics. That's very nice. The fact that a cheap little OEM soft modem gives you that when you ask for it, that's very, very impressive. Okay. Oh, we got more. Okay, that's actually kind of nice. And I'm going to say that's it. All right. So this modem has no sounder on it, so I just have you connected directly to the phone line, and we're going to call the courier. Oh, something is wrong. Yeah, it did dial, but I'm getting no sound for some reason. Why would that be? Oh, that would be why. All right, let's try that again. Very fast dialing. Oh, whoops. take the courier back on hook. All right, there we go, easy peasy. Will it pulse dial and connect to a Bell 103 device? There we go. No problem there. Cool. All right, let's get out into the world. Wow, this thing dials fast. That's very funny. And there we go. Pretty effortlessly. That was a pretty good handshake. Let's try the 2600 network. We'll try it from inside the Northstar system, just because it's a really good, very demanding tolerance test. Well, it fell back to VDOT34, but we did hear the digital impairment learning tone, and that is the standard Azure DIL tone that Azure modems usually have. That other Azure modem we tested earlier, it had a Lucent DIL tone, but it was a much older Azure modem when they were newly spun off from Lucent. But yeah, that's what the standard Azure DIL tone sounds like. If you have a laptop with an Azure modem, that's usually what the DIL will sound like. The fact that we got the DIL is pretty impressive. But I'm going to hang up here. And what I'm curious about now is if it will do V.8 bis, because the 2600 network will not, you can hear just a tiny fraction of a second of v.8 bis, and then they just go silent on it. So the 2600 network really doesn't attempt v.8 bis. But I'm going to try the other number that I have here that does v.8 bis, and we will see if this modem does it, just out of curiosity, right? Nope, no v.8 bis. Oh, wow. Oh, and we have silence. Ah! Wow. Ah! Wow, I don't think we've seen much of that in this video. It just completely fell on its face. You know, it's funny, this modem seems to work okay. It actually works better than the other Azure-based modem we tested, which I believe that was the one I said was the worst modem we tested yet. But the weird thing is, these have been v.90 connections that we've been getting, whereas this is definitely a v.92 modem. And you can tell when a modem is attempting a v.92 handshake because you get the answer tone a second time. You get the answer tone in the beginning, and then after the v.8 exchange, you get the same answer tone a second time. That's very interesting, but it doesn't seem we got as far as the DIL, but it won't actually establish a connection. But on the whole, this modem seems to work okay, so I will give it a pass. Okay, so all we have left are connection-based modems, and so I'm starting with the oldest one. This one was made in 2001. Now, this one was a little bit of work to get working. Windows XP installed it automatically, but the driver it installed was wrong. It just detected the modem as being the wrong kind of modem. The driver it installed was for something called a best data fax modem, and that driver did not work at all. When I opened HyperTerminal and tried typing any commands, HyperTerminal would just lock up solid. So before I discounted the modem as just being bad, I took it out, I looked up the model number on the modem, and I was able to find the right driver that way. Now here's the weird thing, the model number on this modem traces it to apparently being made by Motorola. But why would Motorola make a modem based on a Connexin chip? Motorola makes their own chip. They had already been making their own modems. I'm not sure. But the model number on this modem, the internet says this modem was made by Motorola. However, the driver that resulted from that Google search, which works for this modem, does not call it Motorola at all. It just calls it a Connexin Soft K56 Data Fax Remote TAM PCI modem. I don't know what remote TAM means, but anyway, I think it's just a standard Connexin modem. So, we'll roll through the ATIs here. Here we go. July 30th, 2001 is the driver date. All right, so this modem has a piezo buzzer on it, so you're listening to that. So we'll call the courier. We'll see how good or more likely bad this piezo buzzer sounds. Well, it's not the worst piezo buzzer, but you can tell you're only listening to one side. I think we're only listening to the remote side. We're not hearing anything from the originating side except for when the modem actually dials. We've got a non-haze compatible result code. You know, Connexent was spun off from Rockwell, carried over Rockwell's weird result code format. But it tells us everything we need to know. V.34, 33.6, we got LAPM. I'm going to assume that DR is data compression, of which we've got none. It's funny, on my North Star system, these modems, none of these modems want to enable data compression. It's very strange. So that seems to work just fine. Let's see if it'll pulse dial and connect to the leech. Yes, it does pulse dial. Oh, and there we go. Yes. Oh, gross. Does some gross buffering at 300 baud. But it works. Oh, we get a bunch of garbage when it hangs up. Other than that, it was fine. All right, let's go into a BBS. Wow, that fell right on its face. That's not a good start. Well, Kludge BBS takes some time to reset after a failed handshake, so let's just go ahead and try calling the 2600 network from within the North Star system. I have no idea what the hell is happening. I have no idea what's going on. That piezo buzzer is so bad. Hold on, I think I can connect it to the line right now. We can hear what's going on. And the remote end hung up. Okay. Let's try Kludge one more time. We'll listen to the line. We'll see what it's doing here. Oops. Uh-oh. I wonder if this is going to dial correctly. I think it did. Wow. Wow, this thing's crap. We can't even dial Kludge. We will try a direct connection. But that is a pretty poor showing, however you want to paint it. right, we'll keep listening to the line. We don't got to listen to that stupid piezo buzzer anymore. Wow, what a piece of crap. We will try the 2600 network one more time. Wow. It does the same thing every time. It just, when it gets to, I bet it's because of the phone line delay. This modem was just designed so poorly that it can't deal with the phone line delay, and it gets confused during V.8. What a piece of crap! I'll try one more number and then we'll call it for this one. Oh. What the hell? That may be the strangest hand... that... What a piece of crap. Wow. That may be the strangest handshake. That may be the most broken but successful handshake I've ever witnessed. It started to do what sounded like a V.92 quick connect handshake, which is very strange because I've never called this number on this modem, so it definitely shouldn't have done a quick connect. They started to do V.8 bis, but then it stopped in the middle, and I think the phone line delay just caused that issue again. And then it knocked itself down to V.32. Very strange. I think it all comes down to the delay. Let's try that one more time. Ah, you are kidding me. What a piece of crap. This is by far, I think this is by far the worst modem we've tested tonight. Wow, this thing's terrible. Okay, you know, it functions. It'll connect to Bell 103, but it's a piece of garbage that can't in any way, shape, or form tolerate a VoIP phone line. At least I'm going to assume that's the issue. Wow, this thing's terrible. On to the next one. Alright, well, I'll save all your guys' time as well as mine. Well, not really. I already wasted my time because I tested these modems. All the Connexent modems perform the same, which is terrible. They all connect to the Leech just fine. They will not connect to the Kluge BBS, and they will not connect to any of the 56K capable numbers that I've tried, even when directly connected to the phone line. It just seems like these modems are... they just do not tolerate a delay in the phone line, and I think that is what's causing the issues, is just the delay in the phone line, because the handshake just falls on its face. And that's what makes that even more disappointing. Is these are really modern modems designed in a time when telephone lines were beginning to transition, or were really in the middle of transitioning to VoIP technology, and there was a bit more delay. And so the fact that we've seen some older modems, much older modems today, that deal with that delay just fine, but these much newer modems do not, it's very disappointing, but also not really that surprising. Also kind of funny, a lot of these modems, they say V90, even though, you know, they're obviously new enough to be V92 modems, but also when I look them up, the stuff I find online says they're V92 modems too. So for some reason they just call them V90 here. But yeah, gee, what did I say in the beginning? I believe sludge was the word I used. And it looks like that's exactly how they delivered. Bonus modem. This is our last one tonight, I promise. This modem was actually inside the IBM NetVista, which I pulled out to test some of the modems with tonight, just because I couldn't get them working on the Socket 7 system with the operating systems available to me that would work on the Socket 7 system. So yeah, this was in the IBM NetVista, and I assumed at first that it must have been the original modem to the NetVista that I just never took out of it. But when I Googled the number printed on this sticker, 51850414, this actually comes out to being a Hewlett-Packard part, which, okay. I must have just stuck this in the NetVista for some reason at some point, unless that number does not necessarily denote a Hewlett-Packard part. Maybe, you know, it just denotes the model number from whatever company made the card, and it was used in both HP and IBM PCs. Who knows? But this is another Lucent chipset-based card. It was made in 2000, and this is our final modem tonight. Let's see if we can end on at least a marginal note. All right, well, this Lucent Winmodem from the IBM NetVista seems to be working all right. So we'll roll through the ATIs here. Of course, it's probably going to be the same as the other Lucent modems we've tried because they probably all use the same driver. Maybe not, though. We get we get lots of diagnostics. That's cool. Oops. Okay. Call the courier. This one does have an onboard piezo buzzer. See how loud it is or how bad it sounds. Okay, that was effortless. There we go. Oh my god, terrible buffering. Was the other Lucent modem the one where we saw this? Oh, that is just garbage. That is terrible. Yuck. But it works. And a clean hang up. Okay, let's get out into the world. Okay, seemed like a bit of a strained handshake, but we're on. This is probably a long shot, but I'll see what this does from inside the North Star system. Okay, we definitely dropped out, yeah, so we connected at V.34, so we definitely weren't going to get 56K, but it did connect, and that's worth something based on the other modems we've seen. But I will make a direct connection to the line here, and we will try it again. And I would say yeah. So not that time. I'll try one more number and then I'll call it for this one. What do you mean error? Oh, whoops. Forgot I was on a call. Okay, this one's gonna fall on its face. Alright, put that out of its misery. Okay, so we're not gonna go into 56K land with this, but connected to the BBS just fine. Seems to be an alright modem otherwise. Got really gross buffering going on. But other than those two things, it seems to be okay. And with that, we are finally done. That took a long time, an awful lot of phone calls. But we got her done. And you know what? I've had a lot of fun doing this. It's been so interesting to find out how different types of modems perform. We found out that indeed, a lot of these modems work really, really well. And a lot of them just work like crap. I think one of the coolest things I learned is that there's a lot of really decent soft modems, like this L-shaped US Robotics unit. It works really, really well, actually. I mean, it performed basically as well as that V92 Courier. if I recall correctly, how well that modem worked. Yeah, so what we've learned here is that obviously hardware modems are always the way to go, but not all soft modems are crap. A lot of them are crap, like these connexins. These were just awful, and one or two of those Azure modems, quite disappointing. But not all of them are bad. We found a few soft modems today that I was actually really pleased with how well they performed. But we also learned something that I never realized before, which is that a soft modem can perform like a completely different modem just based on the driver that's installed, which is kind of funny. And yeah, it's been very fun going through all these. As for what's next, I don't really care to keep any of these. I am thinking of keeping this US Robotics Winmodem around for a little while. I'm thinking of making a video about it, just a video about this modem alone, and just going over the features that it has and stuff, because I was really quite surprised at how well US Robotics worked the hardware Sportster experience into a non-hardware modem. So that might be worth a video on its own. This US Robotics Sportster, I'm going to see if I can repair it. I'm not sure what's wrong with it, if it's got a bad relay or what, or some other bad component, but I will try and do some work on it, see if I can get it working. If I can, we'll make a video about this guy as well. I'm really disappointed that this Motorola SM56 couldn't work, just because it would have been very nostalgic for me to hear this thing handshake again. I'll keep it around a little longer. I'll try it in more computers, just see, I'll try different things, see if there's any way I can get it working. I won't put too much time on it though. If I can't get it working, trying it again, this guy's just going to be e-waste, unfortunately. As for the rest of these guys, I mean the modems that didn't work, this Compaq modem, and I forget which other ones didn't work. I'll have to see when I edit the video. I'm not going to waste my time trying to get them working. They're just going to be e-waste. But with the exception of the two US Robotics units and the Motorola, all the rest of these modems, oh, and this sound card combo card as well, I'll keep that as well because of the sound card. I want to keep that in my spare parts. But the rest of these, I'm going to try and sell them. Even the really good, like, completely hardware, like non-plug and play modems, I don't really care to have them. So, serial modems are where it's at for me. So I'm going to list all the working units of these, aside from the ones I want to keep, on eBay. If I've done that already, you can find a link in the description of this video. Otherwise, I will keep you up to date. I'll make a post in the community section of the YouTube channel, or if you go to my Mastodon, the Maritime Girl at tech.lgbt, you'll find a notification there as well when I start listing these on eBay. Some of the better modems, like the hardware-based modems, I'll list individually for sale. All of the crappy, like Connexin soft modems, I'll just list them as a lot. They will all be listed for very cheap because modems in general, and especially internal modems, they're just not worth anything. I don't really care to make a lot of money off them. I just want them to go to a good home. Maybe someone has a computer that they'd like to have a modem in, play around with. Don't have to deal with a serial modem and finding or making a serial cable and all that stuff. Might be a good way for you to get into modeming if you pick up a nice internal modem, like some of these very much are. So anyway, that's what I'll probably do. But aside from that, I had a lot of fun. I hope you guys too. I hope you found this interesting. I did a little measurement. There is 5 hours of footage that I recorded that I now have to edit. So it'll probably be another month or two putting that together. And I can't imagine this video ending up being less than 3 hours in length, and which is probably going to make it just the most ridiculous video I've ever made. Who wants to watch hours of modems making phone calls and handshaking and all that stuff? The answer to that is actually some of you, and me as well. So, so if you are one of those people and you've made it this far, thank you very much for watching. And more videos to come on modems, but on other stuff too. But until then, thank you so much. Thank you to everybody who chooses to support me via Patreon. And I will see you in the next video.